So let me go. Energy, right? Let
Right.
me let me continue where we left off in trigonometry, right? So guys, as you would remember, we looked at 90-degree angle triangles, right? Just remind me, guys, if you have a 90-degree angle triangle, what are the two things you could use?
Pythagoras theorem.
Right? And to use Pythagoras theorem, how much side you need to have?
Um, two sides, sir.
Right. If you don't have two sides, what is the next thing you're going to use?
Sine, sir. Sine rule.
No, trig ratios. Trig
Oh,
ratios. Right? If you don't have two sides, then you're going to use the trig ratios, SOHCAHTOA, right? So under 90 degrees, Pythagoras theorem, if you have two sides, and in all the other cases, trig ratios. Yes or no? We good?
yeah, sir.
All right. If you are not dealing with 90-degree
What
angle,
does that mean?
right angle, triangles, let me show you. Okay. Can you see how this angle, it could form a square? Seeing that? Like if you were to,
Yes.
can we do the same thing over here as well?
Yes.
So anytime you see this little square, it means that the angle between those two sides is 90 degrees, right, Faith? So anytime you see a 90 degrees by a triangle, you could use Pythagoras theorem or you could use trig ratios, right? If not, you can't. Let me give you an example of something that is not a 90-degree angle triangle. Let me ask that question, right? So Faith, does it look like you see any right angles over here? Remember, it's supposed to form like a square, right? Are you seeing
No.
any? No. So you can't use Pythagoras theorem here, and you can't use trig ratios. Understand?
I understand.
Right? And Pythagoras theorem, you need to have two sides. So if you look at this diagram,
So
we
they
actually
must I must be given two sides.
exactly so like 9 and 8, and you must have one missing side. And then you could use Pythagoras theorem. In all other cases, you use trig ratios. So let me just say you have another angle other than 90, right? And you have one side or more, you could use trig ratios. But let me be real, Faith. Faith, if you have more than one side, you have two sides, what are we going to use? If you have two sides, what would you use?
If we have two sides,
Yeah.
Pythagoras theorem.
Yep. Right. Let's just say dealing with triangles that don't have a 90 degrees in them, so non-90-degree angle triangle, aka the ugly duckling. This is the ugly duckling, right? You'll have to use what two things, guys? What are the two things you'll use if you see a triangle that does not have a 90 degrees in it? What are the two things? Remind my guys.
I'm
Sine
just
rule
going
and
off my
cosine
guess
rule.
here. Sine and cosine.
Okay, Faith. Oh, big up you. All right. And how do you know to use the cosine rule? You're looking out for what? Or what kind of angle?
Included.
Yes, included. And an included angle is an angle whose what? Tell me. What's an included angle?
In between two lines.
Yeah, it's in between two known sides. So let me just say I have an angle here. Call this 50 degrees. As it is right now, is that an included angle? I don't check it out, yeah? Yes or no?
No.
No. What about now? Feet, is that included angle?
Yes.
Catcher. Catcher. Feet.
Well, look the angle right there. It says
Right, right. But is it in between two known sides? Tell me, Feet.
no. So to use the cosine rule, it must be in between two sides.
That you know the length for. You must know the length. So you see how we don't know this length? You can't use the cosine rule for this. Or is it an included angle now? Some of it.
I'm afraid to say yes because I'm not seeing a complete triangle.
Yeah. How about now?
Weird. All right, yes.
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 So Faith, can we see that this angle is in between two sides and you know the lengths for each side? If you know the lengths for both of the sides, at right next to the angle is an included angle, right? Why? Because it's included between two known sides. Now, ask a question, Faith. If I were to take that each, right? If I take that each and I move it over here, is it still an included angle or no? Now, before you say anything, right? Remember, an included
Yes.
angle, later, and for angle to be included, the adjacent sides, okay, so the sides right next to the angle, you need to know the length of it. So Faith, can we both agree that this side is right next to the angle? This side.
Yes.
And this side right next to the angle, yeah?
Yes.
Do we have the length here?
No.
So is it an included angle?
No.
No. No. Would this be an included angle over here?
Yes, it would because it would be in between the 9 centimeters and 8 centimeters.
Exactly. Exactly, right? And if that is the case, right, you'll be able to find for the length of the side opposite the included angle, right? So anytime you had to use the cosine rule, look out for an included angle. And the length you'll be finding is the length that is opposite the included angle, right? And guys, if you don't have an included angle, naturally, what's the next thing you have to do? What's the next thing you could use?
Sine rule.
Exactly,
I
sine
know.
rule. Could somebody just remind me what the sine rule looks like?
A over sine A is equal to B over sine B, which is equal to C over sine C.
What about question, right? Are we going to use all three or are we just going to select two based on the information we have?
We have to select based on the information we have in the question. So
Right. We're looking for a pair of information, right? So when I say a pair, what do I mean?
two, sir.
So like, I talk
No, an angle with like side that's opposite from the angle.
yes, yes. So you need the corresponding length for the given angle, right? And then the other one is going to select is based on what you're trying to find for. If I'm trying to find for B, I'll select B over sine B. If I want to find for C, I'm going to select C over sine C. But it really depends on what you're trying to find for. Right? So cosine and sine. Here what? Let's just do some questions, right? And then we are going to look at I need to teach you all angles at elevation and depression, and then we can look at bearings. Right? But I feel like I'll do bearings one time since we already touched sine and cosine rule. Right. So I'm gonna draw a triangle here, right? I want Ollie to immediately tell me what kind of triangle I just drew. What kind of triangle is that?
Right angle
Nah,
triangle.
right angle triangle.
Right. All I want to use
Triangle, triangle.
All right, give me one. Pythagoras theorem or trig ratios. I'm gonna base the example of what I tell now.
Pythagoras.
All right. I'm gonna tie up all right. Yay. What is this length called by chance? What is this length called?
The hypotenuse.
Right. So if I put 9 centimeters over there, right? Could I put 10 centimeters over there? Is that legal? Is that legal?
No.
No, because the hypotenuse is
No, because now it's not next to the angle.
the hypotenuse is the longest line in the triangle. So here it is now. If you do a calculation, all right, if you do a calculation and you get an answer that bigger than the hypotenuse, something wrong, right? Something very wrong because the hypotenuse has to be the longest length in the triangle, right? And I can say that this is 6 centimeters. And I could probably call this side y. So guys, in this example, how much sides do I have?
Two sides.
Two sides, right? And if I
No, you
want,
have one.
no, I have two sides. Watch. I have the 9 centimeters here. That's just for this side. And I have the 6 centimeters over here. That's for this side. Confused, or you understand? When I say two sides, I'm talking about
I
the
understand.
length, right? So let's write down Pythagoras theorem. So remember, Pythagoras theorem is the hypotenuse squared, right? The longest length squared equal to the other side squared plus the other side squared. Right? And mathematically, you'll write E squared is equal to B squared plus C squared. Right? But just putting it there so you'll know what's going on. So guys, in this question, what is the hypotenuse?
9
9
centimeters.
So I'm going to replace A with what?
9 centimeters.
9 squared, sir.
It doesn't matter the order, right? In which you say B and C, it doesn't matter. We need to pick a side. What are the other sides in this question? Other than 9?
6 centimeters, sir.
6 and?
Y.
Right. So again, it doesn't matter. You could call B 6. You could call B Y. Doesn't matter. It'll work out the same at the end of the day. So I'm going to let B be Y. And all I want to say C is 6. Next step, let's probably simplify. But just by looking at this, right? What do you think we want to find for? Just by looking at this, what do you all think we want to find for?
Y.
Y, sir.
Want to find for Y. So let's simplify. What's 9 squared?
81.
81.
Right. 81. Y squared, they can't really do anything with that. I'll leave that blank for now. What is 6 squared?
36.
36.
Right. So guys, the mask got that question, right? What is the unknown here?
Y squared, sir.
Y squared.
Right. If that's the unknown, here what? If something is the unknown and you are trying to find it, whichever side it's on, it should be the only thing on that side. So guys, y squared, the y squared term should be the only thing there. Is it the only thing there?
No, sir. It's
No.
around the 36.
So guys, tell me, what could I do to the 36 then?
You could put it on the other side. Move it over
I
to
can
the
move
other
it
side,
over.
sir.
How much people did I confuse with this? Be real, be honest. If I confused you very badly, tell me. All right, Faith, you there? Faith.
Yes.
So Faith, can you see that the only letter here is Y? Like that's what we're trying to find for. We don't know what Y is. Yeah?
Yeah.
Right? Okay. We are trying to find for Y, right? So Faith, right now, Y is on the left-hand side or is it on your right-hand side? Where is the Y thing?
The right hand side.
Right. If it's there, it should be the only thing there. But if you look over here, you see the Y term here and you see a number, right? Yeah. So you're going to take the number and you're going to move it across because if you're trying to find for something, it should be the only thing on that side. So if I take 36 and move it across, the sign is going to change. So it's going to turn from positive to what? What's the opposite of positive?
Negative.
Right. 81 minus 36. What is 81 minus 36?
45.
So 45 is equal to y squared, right? Right? Guys, is it legal for me to just switch it? That's fine, right? If I say y squared is equal to 45, I confuse anybody there or
Yeah.
No, sir. It's legal.
Yeah, it's legal. Right, I'll still on what say. So guys, we have y squared at the moment. And we want to find for what? What do we want to find for?
Square root
Y.
of 45.
Right. We want to find for y. Right now, y is being squared. What is the opposite of squaring something?
The square root, sir.
Right? So you're going to square root both sides.
Dividing.
Nah, not dividing. The opposite of squaring is square rooting. So you have to find the square root on both sides. So, like I said, squaring something is the opposite. Okay, square rooting something and squaring something, they are the opposites. So they would cancel off. And that would leave me with y. Right? So your answer is just the square root of 45. So plug that into your calculator and let me know what you're getting.
It's 6.71, sir.
6.7.
I forgot to round it off.
Right? And trust issues there, but so I'm gonna just verify that. No, I do it. Square root of 45, right? Okay, yeah, you did it correctly. Good. Cool. And units?
Centimeters.
Right. Is there anybody that did not understand the steps that I followed here? Was there anybody that's really confused?
No, sir.
Yes, sir.
All right. So I want a volunteer. Who would okay, the person that said divide. Who said divide? Don't be scared, eh? Don't be scared.
No, when I say divide, I mean like when I can't figure out the square root of a number, I just keep dividing until I figure out what's the square root.
Yeah, you can do that, but it wouldn't work all the time. But yeah, you can do that like 36. 36 divided by 1 is 36. 36 divided by 2 is 18.
Well, that's an easy one, but 45 was kind of hard.
Kinda hard, yeah. You would just recursively you would just keep dividing until the number you're dividing by and the answer is the same. So like 6 into 36 is 6. So that's your answer, 6. Yeah. All right, so Faith, let's do our question together, right? And then we're gonna look at a trig ratio
Okay.
example. Then we're gonna look at cosine and sine. Right. So Faith, you're not gonna try to confuse you. It's for your own good, don't worry. I'm gonna call this O A B, right? Yes. Okay, Faith. Tell me, right, Faith, which length here is the hypotenuse? Is it OA? Is it AB? Is it OB?
OB.
Right. And if you are confused, it's always opposite the right angle. Always. So cool. Now, if I'm writing Pythagoras theorem for this particular question, my formula is going to be a bit different. It's the same concept, right? So, Faith, we said that the hypotenuse was OB, yes? Yeah.
Yeah.
So we're going to say OB squared, and that'll be equal to what? Tell me, Faith. OB squared is equal to?
OB squared is equal to 15 centimeters.
Wait, I write in the formula. Remember Pythagoras?
Centimeters squared, I mean. Sorry.
No, remember the formula for Pythagoras theorem. It is a squared is equal to b squared plus c squared.
Oh, you mean like that? Sorry. So AB squared plus OA squared.
Right, and it doesn't matter the order in which you write it, right? It's fine. Addition is commutative. It doesn't matter order in which you do it. Right, so next step, we're going to substitute. So Faith, just by looking at this diagram, what is the unknown length? What is the unknown length?
OA.
Right, OA. We're trying to find for OA, yeah? OA.
Yeah.
Now, what is OB?
OB is 15 centimeters squared.
Right, AB?
9 centimeters squared.
Let's simplify. What is 15 squared? 15 squared. Oh, I'll see the new watch I get. Like,
25?
yes. I guess I get this new watch. I could do decimals and all kind of thing. Like, real cool. Casio again. Casio real bad. Yeah. You get 225?
Yeah.
What is 9 squared?
81.
Now let me ask you a question, right? So Faith, what is the unknown in this equation? What is the unknown?
08 squared.
Right. So if it's the unknown, what's the only thing that should be here? What is the only thing that should be there?
Um,
So if you
thinking you mean the letters
yeah, the
that
letters.
represent the length?
Yes, that should be the only thing on the right hand side. But Faith, is it the only thing though? Is it the only thing there?
No.
No. You have 81 there as well. So we're actually going to take the 81 and what we're going to do with it.
We're gonna move it across the number line.
Right? And when it moves across from positive 81, it's going to turn to
Negative.
right. So 225 minus 81, and that's going to be OA squared. What is 225 minus 81?
144.
Oh, this one going to work out nice, boy. What is the square root of 144?
12.
Yes. So OA would be equal to the square root of 144. Right? OA would be 12 centimeters. How do you all feel about Pythagoras theorem? Easy, hard, come on.
Very easy,
Finally
sir.
got it.
You finally understand it?
Answer.
Yeah. I just need to remember to square root. That is what I always forget.
All right. Don't forget it. All right, what about the rest of you guys in class?
So I feel unconfident.
That's good. That's good.
Yes, sir.
Celine, how you feeling? This is light work?
Light work.
Nice. Okay. Let's move on to trig ratios now. And I don't know how much times I will say this, but guys, don't feel shame and don't feel scared. I'm here to help you, right? You're not going to get help if you stay quiet. So talk to me.
Trig ratios, right?
Yeah,
This is like sine and cosine.
sine, cosine, and tangent. So let me give you a quick crash course on that, right, Faith? So there are three types of trig ratios. And you can remember it as so, ka, tua, right? What does so represent? That tells you that sine of the angle theta is just a ratio of fraction, right? Between O and H. So sine theta is just the opposite over the hypotenuse. Cos theta is just the ratio between the adjacent over the hypotenuse. Right? Tan theta, again, theta is the angle, right? Tan theta is just what over what? What do you think? What do you think tan theta is?
Wait, just now, angle over.
Now, check it out again, right? So S stands for sine, right? Theta, and that is O over H. O over H. Ka, in ka, C stands for cosine, right? Cosine theta. A stands for adjacent, and H stands for hypotenuse. So you end up with cos theta is A over H. A over H. The T here stands for tan theta. So what do you think I'm going to put here?
O over A.
Nah, you take it away from Faith. I want Faith to answer that. Right? But Faith, do you understand why it's O over A?
No.
No? Okay. Let's run through it one more time. Right. So Faith, what do you think the S stands for?
Sine.
Right. So sine of the angle theta, right, is equal to O over H. All right, you with me? I confuse you? Or you okay?
No.
Okay, what does the C stand for?
Cosine A over H.
Yes. So the last one now. Tell me what the last one will be.
Theta.
Nah, tan. T is tan, right?
Tan theta
Mm-hmm.
O over A.
Right. So O is opposite. A is adjacent. And H is hypotenuse. All right. And you label
Okay.
everything with reference to the non-90 degree angle. So the angle other than 90 degrees. So I'm going to give you an angle here. So let's just say that this angle is 48 degrees. And I'm going to tell you that the length for this side is, say, 10 centimeters. Your first step is to label your triangle. Label. First things first, guys. This side is opposite the right angle. Anytime the length is opposite the right angle, they call that the what?
Hypotenuse.
Hypotenuse.
Hypotenuse. So if the length is opposite the right angle, they call that the hypotenuse, right? And the hypotenuse is the longest line in a triangle. Right, hypotenuse. Next up. So Faith, if this is the angle in question, can you see that this side is the side right next to the angle? Yes or no?
Yes.
Right. Another word for
Yes,
right
I
next
can.
is adjacent. Adjacent. So this is the adjacent side. And can we see that this side is actually opposite the 48 degrees?
Yes.
So we call that the
So is
that makes sense?
yes.
Right. So adjacent just means right next to the angle you're talking about. Right? Hypotenuse is opposite the right angle, and you're looking out for the slant one. That's the hypotenuse. And
So
well,
that means this one is tan.
wait, let me take the time. I first need to tell you what we want to find for. Right? So I'm going to give you two questions. Question one. Find for E. Question two. Find for each. All right. So guys, if I want to find for E, I need to underline E one time. Right? So I'm going to underline E one time. The next thing I'm going to underline is the length for which I have. What is the length I was given here? Somebody tell me, what was the length I was given? Was I given O,
10
H,
centimeters.
10 centimeters.
and that is O. So what trig ratio has O and E in it?
Tan, sir.
Right, so
Tan.
it was correct. So you have to select tan. Why am I saying that? I'm saying that because you want to find A, so you need one with A in it, and you have O. So you need to use one with that have O in it. So tan, because tan theta is O over E. Yeah. And what is the angle we are dealing with? Tan how much degrees?
48 degrees.
48 degrees.
Right. And that's equal to opposite. What's the opposite length?
10 centimeters.
Right. And do we know what the adjacent is?
No, sir.
Nah. Right. If I write tan 48 as tan 48 over 1, would I be confusing you all?
No, sir.
What about the rest of you guys?
No.
Would I be confusing you all? If you understand, say yeah. Unmute and hit motor vibes or something like, yeah, that's making sense.
Right.
Yes.
It makes sense, sir.
Get
We
that.
have two fractions on either side. What do you do what do you do when you have two fractions on either side? What do we do when you have two fractions?
Cancel out.
Nah, not cancel off. Cross multiply. You cross multiply. You could only cancel off, like, okay, if you had 10 over here and 10 over here, yeah, I guess you can't even cancel off there because you have to multiply by 10 and that'll be 100. Now, I think you're mixing it up with fractions. Like if you had 10 over 10, yeah, you can cancel off, right? But over here, you have something in the denominator on the left-hand side, and you have something in the numerator in the right-hand side, that wouldn't work out. So anytime you have two fractions on either side, you have to cross multiply. And if you don't understand what cross multiplication is, you're just going to multiply diagonally. Now, remind me, guys, is tan 48 a number or unknown from yesterday's session?
It's a number, sir.
It's
It's
a
a
number.
Because if you put it into your calculator, are you going to get a letter or a number?
A number.
A number.
Exactly. So
number.
tan 48 is actually a number. Eh? Don't let it confuse you. It's actually a number. So when we do that multiplication, you're going to end up with A, right, by tan 48. And then you're going to end up with 1 by 10. What's 1 by 10?
10.
10. Right. Now, guys, check this, right? What do we actually want to find for over here?
A, sir.
Faith. We want to find for what?
We're looking for A.
Right. Right now, A is currently being what to tan 48? What's the operation in the middle? Is it multiply? Is it added, divided?
Multiply.
Right. So what's the opposite of multiplying by tan 48? What's the opposite of multiplying?
Divide.
Divide. So to get rid of tan 48 on top, you're going to divide by tan 48 in the bottom. Well, you just simply dividing, right? And yeah, the tan 48s are going to cancel off. And that's going to leave you with A. So my answer is just 10 all over tan 48 degrees. Right? Faye, do you know how to use the new calculator I have?
Well, I saw the tan. I just put 48 and press equal. I'm not sure if that's correct.
Right. Do you know how to put fractions in a new
And I get
calculator?
like 1 point. No.
All
I'm
right.
seeing this knob here.
Okay, you see in this button here that kind of look like a fraction. I real click in it. I real click in it. You see it highlighted?
Yes, I've seen it.
Press that. Right? Then put 10
Yeah,
on top.
press it.
Then press 10, put 10 on top. Then you're going to press the right arrow to go to the denominator. Right? Then you're going to press tan
Okay.
48. Press tan 48, close bracket.
Tan 48. Close
Now press equal.
brackets. Yes. Now press equal.
Yeah, but yeah.
Okay, I got 9.
Right. Okay, can you put fractions exactly how you see it on a sharp? No.
No, I don't know how to do that.
You can't read it on a sharp, right? But like, watch. And just seeing that, you plug it in exactly how you
You
see it.
can't do it on the sharp?
Now, you can't plug it in exactly how you're seeing it. You'll have to put a bunch of brackets. But wait, can you see that exactly how you're seeing it over here
Oh.
is exactly how we put it into the calculator you're seeing now? Like, is it looking like this for you? 10 over tan 48?
Yeah, I seen that.
Right. So it's very convenient with the Casio because you're plugging
Yeah,
it
I
in.
seen it exactly like that.
Exactly, right? That's a
Well,
lot.
not the Casio.
Or the Sunway.
The Quartz too?
Quatsu, whatever.
No, not the Sunway. Quartz too.
Whatever. It's the same thing. I treat it as the same thing. It's the same thing. Right? So should I get 9.00? Everybody got that? 9.00?
Yeah, sir.
Yeah, sir.
All right. People with the sharp, did you get 9.00 centimeters? If you have a sharp and you're struggling with this, let me show you what to do, right? You're just gonna put 10 divided by tan 48, and you're supposed to get your answer. All right? Okay. So let's move on now. Adika, you there?
Yes, sir.
Adika, let me do a question now. Let me do a question.
All right.
Right, so Adika, I'm gonna change up. Actually, no, I'll leave the same question, right? So Adika, help me label this triangle. What would I call this length?
Um, the
Now, be careful when you say, right?
adjacent.
Yes. Now, if you look at the angle, this is where the angle is, right? So the
Yeah.
sides that are adjacent to the angle is this side and this side. But you must understand that this side is opposite the right angle. So this side has to be the what? Automatically,
Hypotenuse.
right. This is definitely the hypotenuse. Definitely. And this is the adjacent. Why? Because guys, watch. If this is the angle, right? That is the line right next to the angle. So it's adjacent to the angle right next to. And this will be side that is what to the angle.
Opposite.
Great. We want to find for each. So what two lengths am I going to underline?
O
We're going to
and
underline O and we're trying to find for.
H.
Right. If you didn't know, now you know, right? That's how you figure out which two to select. Now tell me, Adika, which trig ratio has O and H in it? O and H.
Sine
Right. Sine theta is equal to what over what?
is equal to
So,
A O over H.
right. What's my angle?
48
Right? What is O?
over 10 centimeters.
What is H? Just H, right? Just
Yeah.
H. I'm going to write sine 48 degrees or sine 48 degrees over 1. You are seeing two fractions on either side, so what should you do?
Cross multiply.
Right? Tell me what the next line would look like then.
It will be H sine 48 degrees over
Now over, equal,
or equals to 10.
right? Because 1 by 10 is
10.
right. What is the unknown here? What am I trying to find for?
You're trying to find for H.
So what? Wait, right now H is being what? What is happening to H right now?
Multiplied
It's being multiplied by what?
by sine 48.
So we had to get rid of that, right? So to get rid of it, we're going to do the opposite and multiplying by sine 48. We're going to divide by sine 48. And if I'm doing something on one side, I need to do it on the other side. So just like that, you get your answer. How you feeling about this?
Very good.
Easy or hard?
It was easy.
Right? Plug it into your calculator, right? So 10 all over, right? So 10, so feet. What you could also do, right? You can put 10. So feet, you can put in 10, right? You can put in 10 into your class, whoever. I call it the ghetto Casio. But doing the job, right? Doing the job. And it's fine. I honestly, if I was in your shoes, I'd just buy the class 2 or the Sun. I'm not spending so much money on a Casio. Right?
Yeah.
Press 10, press the fraction button, right? Press 10, then press the fraction button. You should see the cursor is already in the denominator. You just have to put sine
Yeah.
close bracket. Let me know what you get.
I get 13 points.
Oh, that's why I got the syntax error because I forgot to put the brackets. Okay.
Yeah, you need to put the brackets. Watch, if I leave the brackets out, syntax error. Right? Please
Yeah.
put brackets. So guys, exactly how you see me putting it, exactly how you write it in the exam on the paper is exactly how you're going to plug it in into the Casio. So guys, that will be 13 point forward. Forward. From a faith. 13 point forward.
13.45.
Now, what's the number after 5?
6.
Is 6 5 or more?
Yes.
So you're going to increase 5 by 1 and drop everything out. Drop everything else. So that's going to be 13.4.
All right.
13.4. So you're going to increase 5 by 1. If you increase 5 by 1, what is going to turn to?
You're gonna turn into 6.
Yep. Guys, do we have a problem with these types of calculations, or are we okay with these types of calculations?
I'm okay with it.
What about the rest of you guys? Is there anybody that doesn't understand the cross multiplication, which two to pick, how to label the triangle? Selma, Selma, Selma. Don't be like this. Don't be like this. Scream out loud if you have to. Right? Scream out loud if you have to. Just don't scream quietly. I can't hear
And
if you scream
don't,
quietly.
and don't do like me and use AI because that will make Sir get pissed.
Oh yeah, yeah. Oh bald. I mean, you could use AI, yeah, but I
But
like I use AI a lot to learn, but I feel like okay, a student that has extreme problems in maths probably shouldn't use AI.
Yeah, AI doesn't work for maths. I try. It does only work for
No,
like biology and
no,
subjects
no,
like that.
no, you're wrong. You're wrong. I use
it
by
does look maths.
I I
Yeah,
use
it does work for maths.
I use AI for my
No, but if you
history
already
level
don't
maths.
understand maths, is failure.
Okay, well, yeah, yeah. If you do have some level understanding, the AI, okay, AI is gonna talk very objective and using the mathematical jargon. You see how I'm watering it down for you guys and taking it one step at a time? AI will be like, right, so apply the inverse function there, right? Additive inverse, all of this fancy mojo, and that might confuse you, right? So yeah, AI is, I don't think for students at a real loss and they don't know anything in maths, probably not the best idea. But for like the top students or students that have some grasp on maths, it's fine. And I would recommend the use. Yeah.
I think that is why I guess Sir trust his user a little bit now with using AI just once.
Yes, yes. Because for sure, I don't mean this in a bad way, but I feel like you still have a lot to understand in maths. And if you use an AI, you go learn a bunch of different things and it might confuse you. You need to understand the base first before you can use AI.
So I'm not using it no more. I promise that. I'm not using it no more.
Okay.
That was only one time. That was just one time.
And it's so fast I figure it out too, eh? I was like, I know you use an AI.
So question.
Yeah.
Basically, okay, when you multiplying it, right? So say for example, right? Like how okay, so say we have the example you have there, 8 sin, right? 48 over sin, right? Remember you told me that you mentioned that it was illegal or something, or you could like scratch out the sin or the sin don't want to be there, or like because like say you have the 40 on top and or underneath you could put like one and then you do the opposite when you're multiplying it to divide it. So that does confuse him a little bit.
Okay. I think you're confusing when to find for angle versus when to find for length. So here what?
Oh, it's for angle for length. Okay.
Let me do a question, right, Dari? Do a
Yeah.
question together. I'm gonna call this O E D, right?
Mm-hmm.
First things first. Let's just get some lengths, right?
All right.
Let me just call this 37 degrees, right? I'll call this 15 centimeters. All right, so Dari, first things first, right? Which length here is my hypotenuse?
15. B-A.
Great, that's the hypotenuse.
Yeah.
Okay, which one is the adjacent? So which side is right next to the angle? I don't mean 90, yeah? That's all,
O-O-A.
right? This is the adjacent.
Yeah.
And this is the opposite, yeah?
Yeah.
So what if I want you to find for E? Right? If I say find for E, find
It will be tan,
E.
which
No,
is
no,
O-A.
it wouldn't be tan. Let's
It will be tan.
so you're gonna underline where you have. What length do we have? What length do we have?
15 centimeter.
Right? What length am I trying to find for?
A.
Which one have A and H in it?
Huh?
Ha, right? So which one that will be? Sine, cos, or tan?
Tan.
No, no, no.
Hold
Watch.
on, I'm not sure.
Check it out. That's so
Wait, why isn't it tan?
O-O-A.
it's not tan, it's not tan.
Understand?
Which one have A and
O-O-A.
H in it? Which one have A and H in it?
Cos.
Right, you have to use cos.
Yeah.
So you'll say cos theta is equal to A over H. What is the angle?
37 degrees.
Right? What is A? Do we know what A is?
Nope,
No,
you
we got
don't.
O to E, right?
Yeah,
It's O to E. So I'm gonna write O to E. Right? What is H?
15 centimeter.
Right. So look at what we're doing carefully, right?
Mm-hmm.
I'm going to write cos 37 as cos 37 over 1. That's a legal move to make. That's fine.
Okay, I now see this. I now see that.
Now I'm going to cross multiply next.
All right.
I'm going to multiply 1. Hear this, right? What's the unknown here? What's the unknown?
OA.
OA.
Yeah.
I'm going to do that multiplication first. So I'm going to multiply 1 by OA. Where's 1 by OA?
1,
Now, where's 1 by 5?
5.
So where's 1 by OA?
OA.
Exactly, right?
Yeah.
Right, that'll be OA. And then over here, you're going to multiply 15 by cos 37.
37, yeah.
So 15 cos. Okay, this is an easier example. I'll share a harder example shortly. But plug that into the calculator and you're supposed to get an answer. Yeah. Plug that into your calculator and let me know what you get. So 15 cos 37. What are you getting?
So I have the answer, but I'm not sure if it's correct. I get 11. Wait, hold on. 11.9. I'm not sure if it's correct or if I do something wrong.
Am I correct? And
Correct.
the number after 9 is 7, right?
Yeah.
And so the second decimal place is 7, right?
7, yeah.
Number after 7 is 9. So
Yeah.
since 9 is 5 or more, you're going to add 1 to the 7.
37, so it could be 11.98.
Yeah. Right?
Yeah.
So that was that. Was it that hard? Like, I don't know
No,
what
sir. No, I get
the previous example was a little different, right? So let me just run you through the previous example. In this instance, we had to use sine. Now, sine theta is over h. So we ended up with sine 48 over 1 is equal to 10 over h. So we then proceeded to cross multiply. What would this work out to be? You tell me. What would this work out to be?
Oh, sine 48.
No. You're multiplying this by this.
Each.
H what?
Age 48.
No. H sine 48.
Sine 48.
Let me
Okay.
explain something, eh? Okay, be honest with me. You think sine 48 is a number or is a variable?
A number.
Right. So sine 48, plug it into a calculator, is actually a number, right?
Yeah.
Oh, you are multiplying h by this entire number over here. So you need to write h by sine 48.
Yeah. Okay, I get.
And then I'm going to multiply what by what?
1 by 10, which is
1 by 10.
Yeah, 10.
Right. What's the unknown here?
H.
H. I know h is being multiplied by a number. What's the number h is being multiplied by?
Sine 48.
Right. If it's being multiplied by sine 48 and I want to get rid of the sine 48, what's the opposite of multiplying by sine 48?
Divide sine 48.
Yeah. And if you do something on one side, well, obviously, you need to do it on the
Next side.
right. You understand this 100% now?
Yeah. 100% now. So it's so much. I get.
No problem. And as you can see, watch, sine 48 into sine 48 is 1, and 1 by h is h. Right? So that just leaves me with h simply. And so h is the 10 over the sine 48 degrees. Right? So 10 divided by sine 48. And you should get 13.46. Let's verify that again now. 13.46. Verify.
Yes, sir. Good.
Okay. The next thing you need to be able to do is you should be able to find for angles using the trig ratios. So we're going to look at two examples on this, right? Then I'm going to move on to non-90 degree angle triangles, right? Then we're going to look at bearings, do some past paper questions. Then we could look at angles of elevation, and that'll be it for trigonometry, right? After which, I'm going to give you all like a 15 minutes break, come back, grind algebra, real grind algebra. And after algebra, relations, functions, and graphs. We good? Let me know, guys.
Yeah.
Yes,
Alright.
sir.
Okay. So guys, if I want to find for an angle, right, using the trig ratios, how much sides do I need to know?
2 sides.
Exactly. I need 2 sides, right? Right. So finding angles using trig ratios. To do this, you need 2 sides. And let me explain why. Guys, in maths, you can only solve an equation when you have how much unknowns? In maths, ideally, you want to have how much unknowns?
1.
1, right?
1.
1. If you watch, remember, watch this, guys, watch this carefully. Let me look at sine, for instance. Sine theta is equal to O over H. How much variables is seen here?
Two.
I'm not sure. 3?
You
3.
see in 3.
3. I see in 3. And if you're confused, and theta is an angle,
Oh, yeah.
you could put in anything for the angle, you know. So that could change. If I'm changing it, it could vary. It's a variable, right? I could put anything for theta. I could put anything for O. I could put anything for H. If I do not have the lengths for 2 sides, you know what's gonna happen? I go have 2 unknowns. And you can't solve anything if it's 2 unknowns. Here's my point. If you get a question right, and they ask you to find an angle, and the only thing you know is opposites, how much unknowns you have there? So we know the opposite is 5. So that get rid of one of the unknowns. How much unknowns I still have?
2.
Yeah, I have
And
2.
you can't check your answer with only like one answer, with one number. So you'll never know if you're correct.
Exactly. Right? You'd have to solve simultaneously. But you need 2 equations for that. We only have 1. That would not work out. The point being, if you need to solve anything in maths, you need 1 unknown. Right? So I'll put another note here. Must have 2 sides. Must have 2 sides. If you don't, pressure and you can't do anything. So let me give you an example. Let me just say we wanted to figure out so I call this L, M, N. Let's just say I gave you a question, right? And the question was, find 4 L, N, M. First things first, guys. Would you be able to understand what angle they are asking for using this notation? Yes or no? Because we did it a lot when we was doing circles. L and M. Is anybody confused when they see L and M?
No?
Okay, then let's tell me, right? When I say L and M, am I talking about this angle?
No, sir.
Yes, sir.
Am I talking about this angle?
Yes, sir.
Yes.
Yeah, and if you are confused, just think of it like this. The letter in the middle is the angle we are talking about, so angle N. And if you want to go a step further, watch. L, N to M. L, N, M. You can see the angle here is in the middle. That's why N. Simple. So we in this question, we actually want to figure out what this is. Okay, anybody confused so far? Is there anybody that's confused so far?
No, sir.
All right. Before we continue, let's label our sides, right? So guys, if this is the angle we are trying to find for, this is the angle we are trying to find for. What am I going to, first things first, what am I going to label this side? This side is opposite the right angle. So what's the name for that?
H, we'll label it H.
Right? And this, we want to find for this angle, that's it again. We want to find for the angle. this side is right next to the angle we are trying to find for. So what are we going to call that side?
Come on, em.
No.
Wait, sorry.
Now, you only use a notation when you're dealing with triangles that that don't have a 90 degrees in them. We're still dealing with right angle triangles. So adjacent, hypotenuse, opposite, right? So tell me, if this is the angle, right? This side is what? What's another word for right next to?
Adjacent.
Right. Can you all see what I mean by when I say adjacent? Like watch. You see what I mean? Like it right next to. Or that confusing you? How much of you guys are confused? Someone. So this is the angle here, right? Adjacent is the side right next to the angle. So if this is the angle, as you can see, this is the side right next to the angle. And if that's the case, I would say that this side is the what? What is our side? That side is
Opposite.
The opposite.
right. That side is the opposite. So let me ask you all a question. What two sides do you have?
Hypotenuse and A.
Yeah.
And adjacent.
What trig ratio has A and H in it?
Cosine.
Right. So cos theta is equal to A over H. Right?
A over H.
If you are confused, remember, so sine is opposite over hypotenuse. Cos is adjacent over hypotenuse. Tan is opposite over adjacent. Right? So I use cos.
Okay, that makes more sense.
Say okay with me, right, Faith? We okay?
Yeah.
And do you understand? I'm picking cos because I have A and I have H. Yeah.
Yes.
And the reason I'm doing this is because for you to solve anything in maths, you need one unknown. So when I substitute everything, right? What is the only unknown I have now? What's the only unknown here, guys?
The cos
The
theta.
angle.
Theta. Theta is the only unknown, right? So to find the angle from here, you will need to apply the inverse function for cos, which is cos inverse. So theta is just going to be cos inverse, right, of 6 over 10. So plug that into the calculator and let me know what you are getting. So people with the Casio, the Sunway, the Quast 2, you're going to press Shift, cos. You should see cos inverse pop up. Then you're going to press 6, fraction button, 10, close bracket, and tell me what you get.
So I got 53.13.
Faith, I want to hear what you get. Perseus, I want to hear what you get. And Celine and Ariana, I want to hear from you guys too. Dari, everybody.
I don't know
Okay.
how to do it.
You know how to do it or you don't know how to do it?
So I got 53.1.
I'm not getting the inverse.
Here we're going to do, right? You're going to press Shift, press and Shift. See my press and Shift? I kind of highlighting it. See any shift?
Yes, I'm holding it down.
You said I'm violent, boy. Holding it down. Right? Press Shift, right?
Okay, I get.
Right? Press Shift,
Hit
cos.
press.
And if you notice something, right? Look, above, and this shift is yellow. Shift is in yellow, yeah? Seeing that? And you see, this shift is
Yeah.
yellow. And you notice the cos inverse is in yellow. Watch out.
Well, they're
Shift.
not really changing colors.
No. Like I'm talking about right above the cos. You have a little cos inverse that's in yellow.
Oh yeah. Yeah, I have it.
So what I'm saying is like color coded. It's color coded. So if you want to get the cos inverse, you need to press Shift cos, right? And the little yellow above tells you you'll get cos inverse. So that's what I was saying, right? So let me know again, Faith.
Do I have to close it off with a comma?
Comma. No. And I close it off with a bracket.
Do I have to close it? Okay.
So
Okay, well, I only get a bracket on one side.
you can show more ways.
Okay, wait. Yeah, I'm gonna start over.
Right? So run through this steps with me, right?
Shift.
Shift, cos, right?
Mm-hmm.
Then press the fraction button, right? Put 6.
Yeah. No, wait, I press.
I should have like a session where I just show you how to,
Okay, I'm 26.
right? Then press the right arrow. You should be in the denominator now. Then press 10.
Yeah.
Then press the
10.
right arrow. Press the right arrow. That should take you outside.
Yeah. Oh, okay.
I'm gonna make it.
Okay, again, 53.13.
Yep. So Dari, I want you to do a question, all right? Because I know you was having some trouble with this. By the way, this is not a length we are finding for. This is an angle. So you'll say degrees. Don't say an angle. I mean, what's it? Don't say a length, eh? We clearly finding for an angle here. So it's degrees, not centimeters. Are we okay with this?
Yes.
All right. Dari, you there?
Yes, sir. Talk to me.
Right. So let me look at a slightly different application of this question. I'm gonna make things look a little complicated. Right. So Dari, we in this example, let's try to find the angle MLN. Right? Find angle MLN. Right? And if you confuse, watch MLN. Can you see that the angle is over here in the middle?
Yes,
Right.
because the two lines touching.
Yes.
Yeah.
Yes. Let's label quickly. If this is the angle in question, right? Right? What is the side right next to this angle? So this is the angle here.
Hypotenuse.
Here, what? Let me just start off with hypotenuse, right? I think that's the easiest one to start off with. What would I call this line? Tamadari, what would I call this line?
Yeah, that's the hypotenuse.
Right? Cool.
Yeah.
Hypotenuse. Okay. What would I call this line?
M and N.
Now, what I call it? It is what?
Yeah, adjacent.
Nah. That angle is what? No, that side is
Opposite.
opposite. Yeah.
Yeah,
The
what?
opposite.
Opposite. It's opposite.
Yeah.
And Dari, this side over here is right next to the angle. It's right next to the angle. So there's another word for right next to.
Right next to.
Yeah, right next to. It's another word for that.
Like the same, like near.
Adjacent.
Adjacent, right?
Yeah, that's the fancy word for it. Adjacent. Right. So Daria, I want you to select the two lengths I have. What are the two lengths that I have?
6 centimeter and 10 centimeter
So that corresponds to O1.
each.
Right. Which trig ratio have O1H in it? Sine, right? So I'm going to write sine theta is equal to O over H. Nice.
Each, yeah.
Do I know what the angle is?
No.
Nah. Right? I'll leave that blank. What is O?
6 centimeter,
Right? What is H?
10 centimeter.
Right. So we need to apply the inverse function of sine which is sine inverse. So if I want to find the angle theta, it's going to be sine inverse of 6/10.
6/10, yeah.
So plug that into your calculator, let me know what you're like at.
36.87, sir.
Okay, what about the rest of you? Could you all verify that? 36.87.
Yes. So just to be clear, right? To find the missing angle, we use sine inverse, correct?
You
Of
use sine
whatever,
inverse. Yeah.
whether it's sine, cosine, or tan.
No. If if you're using cos inverse. If you're using sine inverse. If you're using tan inverse. Understand? It depends on what ratio you come up with. So, like, Faith, in this question, you had E and H, yeah? Faith,
Yeah.
in this question, you had E and H. So, we decided to use cos.
Yeah, no?
And you know. So, if I'm using cos, it'll be cos inverse, right? Because the opposite of cos is cos inverse. Over here, though, I use sine. So, the opposite of sine is sine inverse. Understand?
Yeah.
It's dependent on what you're using, which ratio you're using. So you're supposed to get 36.87 to 2 decimal places. Are we okay with that?
Yeah, I got that.
Nice. So guys, are we okay with right angle triangles?
Yes, sir.
All right. Nice. What about the rest of you guys? Yes or no?
Yes, sir.
Okay. And while we're on this topic, I should probably show you guys how to find area for a triangle that doesn't have its perpendicular height. It's finding area of aren't you all accustomed finding the area of a triangle using a half base by height? Yes or no? Yeah or no? Tell me, guys.
Yes, sir.
Yeah. But to use our formula, right? You need the base and you need the height. Not the slant length, the height. The height that is perpendicular to the base. Yeah? Right? But sometimes they like to tie you guys up a little bit. So to use this formula, you need an included angle. So check this out quickly. And this works for any triangle, right? Any triangle. Okay. By the way, I'll ever wonder why is this called trigonometry?
Because of the trig ratio.
Well, tree means three sides.
Yeah.
Trig means three sides.
Let faith cook. Yes, that's why.
So I feel it is called it that because it is trick on your brains and as well. So
Triangles. So guys, I draw a crazy triangle here, right? Check this out. Let me just say the angle is 51 degrees. Let's just say that this is 9 centimeters and this is 8 centimeters. Call this A, call this B, call this C. Tell me, guys, explain to me, tell me. Are you all, like, just when you look at this, are you able to clearly see the base on the height? Do you even know what the base is over there? I don't really know myself because, like, what is the base going to be? Right? Maybe if you rotate it like this, you can see that this is the base. But do we have a perpendicular height? Yes or no? Tell me, guys, do we have a height? Yes or no?
sir.
No, we don't. We do not.
Oh,
We do not. No, we do not. Are you? Well, let me guess. Let me guess. You all are thinking it's 9. Yeah or no? Be honest. Be honest. It's fine. It's fine.
no.
If it, guys, math is a very literal thing, eh? Real literal. Are you all seeing a line here with a length?
90 degrees.
No. No. Are you all seeing a length over here? Tell me yes or no. Are you seeing a length?
No.
No. No, I'm not seeing a length. Right? So in situations like this, where the triangle is kind of crazy, you have to use this specific formula I'm going to show you here. So the other formula for area of a triangle is a half, right? Adjacent side by adjacent side, right? Sine of the included angle. Yeah. So guys, can we see an included angle over here? Yes or no?
Yes.
Yes. What is the included angle here?
51 degrees, sir.
Can everybody see that? Can everybody see that you have an angle here with two known sides? Yes or no?
Yes, sir.
Yes.
Right.
Yes,
That
sir.
again, we call that included angle, right? Right. And if you want to find the area for this, it's just going to be, so A is going to be a half. When I say adjacent sides, I'm referring to the sides that are right next to the angle. So what are the sides right next to the angle?
9 and 8.
Right.
9 and 8 centimeters.
Right. And if you specifically label the triangle, tell me, guys, is this like a right angle triangle or a non-90-degree angle triangle? What would you all say?
None?
None.
None, right? And you're not seeing any 90s over there. So if this is angle A, what would I call this side?
Common
Come
A.
on, A.
If this is angle C, right, what would I call this?
Come on, C.
If this is angle
Common
B,
C.
right, call this common B. So the formula for this is going to be a half, right? BC sine what? What's the included angle,
51, sir.
right? So, and that 51 corresponds to angle E. Yes or no? Let me follow you understand this.
Yeah.
Yeah, sir, I get it.
All right,
Yes,
so
sir.
let's apply it, right? So it's going to be a half. Now B is, what's the length for B?
8
sir.
centimeters.
What's the length for C?
9, sir.
Right? And what is the included angle?
51 degrees, sir.
By the way, if you're doing a paper 3, expect questions like this. I saw they brought a question like this and they asked you to find the height. It was really interesting. It's a really, really interesting question. Let me show you what I'm talking about. How much of you guys here are going to write a paper 3?
I am.
Me too, sir.
Okay. So maybe I should do that question with you guys. What do you say?
Yes, sir.
Yes.
What do that? Get ready, boy. I do that just get ready. I had to be somewhere. Wait, dude. Come on a second. The car just vanished.
So for the last question, I
Mhm.
just trying to remember it's 0.5. I plug it into the calculator, right?
So, in place of a half,
Yes.
Yeah, but you have a Casio now, right? So you could plug it exactly how you see it, right? So you can press the fraction button, one, then press the right arrow, right? Two, then right arrow again, open bracket, 8, close bracket, open bracket, 9, close bracket, sine, open bracket, 51, close bracket. So Faith, can you see that we are plugging it in exactly how you're seeing it? Exactly how you write it is exactly how you
Yeah.
plug it in, right? And you should get 27.97. You get now? Some of it. Let me figure it now.
Yeah, I get it. But I get 27.978.
That'll be 27.98. If you round it off,
Yeah.
right? And if you find an area, right, and the length is centimeters, what would the unit be for area? You get area when you multiply two dimensions by each other. So it's centimeter by
Centimeter square.
right. Centimeter by centimeter is centimeter squared. Great. Now I'm looking for that question. I know I did that question. Give me a second. Never mind, it wasn't. Nah. See, that was an odd maths question. I confused myself. What? Yeah, I confused myself with the odd maths question. Let's see. Never mind. Right? But you still need to know this. So, guys, do you all understand how to find the area of a triangle with an included angle? Yes or no?
Yes.
Yes, sir.
All right. So once you see a
Does this only come for paper 3 or paper 2 as well?
paper three and paper two, it's gonna come from. Right?
Okay.
So I have trust issues, right? So let me do one more question, right? And then we're gonna move on to ugly triangles like this. All right. So who wanna do this question, Uma? Do I have any volunteers? They don't leave my
That's
hanging.
all in for getting.
No, no, I put in the information. Don't worry yourself. Don't worry yourself. All right. They get scared. They was like, what? 8.7 centimeters and 8.0 centimeters. Right, who wants to do the question with me? I promise it's not hard, guys. But don't leave me hanging. I'll never break my heart.
I could do it.
Thank God. Thank God. Big up you. Right? First things first, I will label the triangle, right? If it's an angle M, what would this side be called?
Come on, M.
Right? If it's angle L, what would this side be called?
Come on, L.
Right? If this is angle N, what would this side be called?
Come on, N.
Celine, that's you?
No, these are the car.
Adika. Okay, okay. Kind of sound like Celine a little bit there. Right. So, Adika, the area formula is going to be a half what?
A half by
Yeah.
um
Remember, is the product?
M squared plus
Nah,
N.
nah, nah. Mm, mm, mm. Nah.
Wait, MN?
Yeah, yeah. A half
Yeah.
MN, right? Sine.
Sine and then the angle
So, the included angle is
L.
right. So, it's a half, right? It is a half multiplied by the the adjacent sides, sine of the included angle. So what's M?
M is 8 centimeters.
N is?
N will be 8.7.
Right? And the included angle is?
51.
Nice. Plug that into your calculator and let me know what you are getting.
Um, 27.04. It'll be 0. Yeah, 04.
Okay, can somebody else verify that?
I got that, sir.
What about the rest of you guys? Did you all get 27.04?
Yes, sir.
Okay, great. So guys, anytime you have an included angle, right, this is how you find the area. Please take this and please remember this. Please. It's a half by the product of the adjacent sides, right? Sine of the included angle. That's it.
You could find the area if you do have an included angle.
Yeah, if you don't have an included angle, more than likely you'll have to use a half base by height, right? And to use that, so let me show you something, right? Let me give you like an application type question that you could get in the exam. So find the area of the following triangle. So I'm going to come up with this. I hope I'll give you a valid question. But the concept is there. Let's just say you get this triangle, right? Okay. I'm coming up with something. Come on. Before you choose something, it really not that hard, eh? I promise you, it really not that hard. But this is going to apply everything you learned thus far, right? So they want us to find the area of the following triangle. Sure, not a problem. Now, remember, I just want to remind you guys, right? The other formula for area of a triangle, right? So area of a triangle is, does anybody know area of a triangle? What's the other formula for area of a triangle? Does anybody know? It is a half what?
Base by height.
And this height must be the perpendicular height from the base. Yeah?
So could you also write the formula as base by height over 2, right?
Yeah, that's fine. Let me explain why. A half multiplied by b by h. What is 1 by b by h?
BH, sir.
Right? And over here is, where's 2 by 1 by 1?
2.
Right, so I that one is fine. Yeah, I that one is fine. I prefer to write a half base by height, but if you write BH over 2, yeah, that's fine, also fine. So guys, let's just say in the question, they say that, right, so they say length. So they say that length OB is equal to 50 centimeters. And let me just say they give us an angle over here. And let's just say the angle is, take a measurement real quick. So somebody who's have a hard time with measurements, I want you to try to measure this angle from. What does that look like? How much degrees? Let me see if you all can figure this out.
50 degrees.
50 degrees, not quite. 50 degrees would be over here, right? This look like, so this is 45.
All right, so that is
48.
I would say 48, right?
48.
I would say 40,
Yeah, 40. Yeah.
right? Right, so this is a question that could come in the exam, right? And it could be like, find the area of the following triangle, right? And they could give you a length. So guys, let's see how we could do this question. Who wants to do the question with me? Do I have any volunteers? It's for your own good. Or it should be ecstatic. Or it should be like, pick me, pick me. Hey boy. I see Faith on mute. Faith, you want to give it a go with me?
I could attempt, but though is like it's how my brain does work. I would just keep going, right? I'm gonna let me assume we could assume that this x over here is 1 to find the answer.
You want to assume as 1?
Like we can make an assumption to get to the answer. Yeah.
Listen. Let me hear
Like
what
we could agree this is 1x.
that is 1x. Yeah. This is 1x. This is 1.
I want to divide 50 by 5 to figure out what x is.
Okay.
Because I don't know what x means.
My bongs performance. Oh, let's see what she just did. Let's see what she just did. So
Yeah.
watch what she just do, right? If this length is x, right? And this length is 4x, how much is this all together? If you have 1x over here and 4x's, how much x's do you have representing OB?
Five x.
If you're confused, right, watch. How much x's is he in here? Somebody tell me how much x's is he in?
1.
So this,
1.
right? How much x's is he in over here? Don't tell me 1, eh? How much x's is he in?
4.
4. How much x's you have all together?
5x.
Right. So the 5,
5x, sorry.
the 5x represents the entire length OB. So I'm going to write that over here. So length OB is also 5x. So 5x is equal to 50 centimeters. If that is the case, what would 1x be equal to? What by 5 is 50?
Wait, can you repeat
10.
that?
What by 5? Okay, so 5 by what is 50?
5 by 10.
The answer is 10, right? You can do that if you want. Just say x is equal to 10, that's fine. If you want to do the full working, though, you can divide both sides by 5. Right? And if I divide both sides by 5, x would be equal to 10 centimeters. Is everybody okay with what I did so far? So again,
Yes.
asking us to find the area, right? They want me to find the area. Now, I'm not saying I included angle, so more than likely, I'll have to use a half base by height. Now, here the problem. Guys, we have the base here, but what am I missing? What am I missing? I have the base, but what am I missing?
The height.
The height, sir.
Height?
Exactly.
Base by height. Yeah.
I am missing the height. Now, in the question, they drew a line from the top to the base, right? And we know that that would form a right angle triangle, yeah? Can you see the right angle triangle that's being formed?
Yeah.
So what I need to do now is to figure out what the height is. Now, question, guys. If I know that x is 10, right? I'm going to replace this x with 10, and I'm going to replace this 4x with what?
40, sir.
Okay.
If you're confused, right? Remember, x is 10. X is 10 now. So 1x is just 10, and 4 by 10 is 40. Is anybody real confused?
Yeah.
Not really.
Yes, sir.
Okay, so guys, do we understand that this length over here is 40 centimeters? This length over here is 40 centimeters.
Yes, sir.
Yes.
So look what I'm going to do, right? I'm going to extract that triangle. I'm going to take that triangle and I'm going to extract it. Right? So this is O, this is E, right? And I could call this middle point. What do I want to call this middle point? Probably call that C, right? So OAC. If at any point in time I lose it, just tell me, right? Tell me. What is this length? I mean, what is this angle in the middle? What is this angle in the middle?
48 degrees.
48.
48 degrees.
And we are trying to find for what again? If I want to figure out the area of this triangle, what do I need to know first?
The base and the height,
Yes.
sir.
Right.
Then
So what is the height here? OA, AC, what is it?
O to A.
No. If you want to find the area of
Then
the angle, it's
AC, sir. AC is the height.
now OA is not the height, that's the slant length. If I want to find the area of a triangle, I need to know its base and I need to know the length that is 90 degrees to the base. And so not this. Did I clear up the confusion? Or are you still confused?
yeah.
So watch. Check this, right? See this triangle here?
Yes.
For me to find the area of this, I would need to know this height and this base. It's always the perpendicular height, never the slant lengths. Understand?
Yes.
All right, nice. And don't feel shame on thing, and don't feel like I'm calling you out. We learning here. It's fine. It's fine. It's fine. Right? If anybody make fun of you, I'll come for them. I'll be like, I will be like this. Don't make fun of anybody, guys. Because that you never know, like that could be you. Like sometimes I'll be saying some soft stuff in maths, like I'll be saying some soft stuff when I'm tired. I don't want nobody to laugh at me, so why laughing at somebody else for? Everybody's make mistakes. It's fine. Once you own up for them and you admit you're wrong.
So is this tan?
No.
Is
Oh,
this tan rule?
it's a give me a second. Just by looking at it, I can't tell. I probably could have, but I'm gonna look at it fast and I'll tell you. So H,
I put back the 40 centimeters
yeah, it's tan.
because we know that.
It's tan. Excellent. So guys, watch. We want to find area, right? We know what the base is. We need to figure out the perpendicular height. So guys, could everybody agree that we need to find for AC? Yes or no?
Yes.
Yes, sir.
Right. We just figured out what this length is. This length is 40 centimeters. So is anybody confused?
No, sir.
No. Okay, good. Let me ask you a question. What would this length be called? What is this length?
D.
Hypotenuse.
Hypotenuse.
Right? This length is called the what? It's right next to the angle. What would I call that?
Adjacent.
Adjacent.
And this length is what to the angle?
Opposite to the angle.
Right. So I'm trying to find for what here? First off,
The opposite.
right. So I'm going to underline that one time. I need to figure out the height, right? So that corresponds to AC, right?
Yeah.
Which corresponds to O. Okay. And what do I have?
We have A.
Right. I have E. So if this question, if this does come, probably be like a 5-mark or a 4-mark question. It's a multi-step question. It requires you to think. Right? So which trig ratio has O and E in it?
Wait, repeat that.
What trig?
Cosine?
Answer.
Somebody said cosine. Let's go. Let me take a little step back.
No, it's tan.
Let me take a little step back. Remember, sine, so, opposite over hypotenuse. Ka, cos, adjacent over hypotenuse. Toa, tan, opposite over adjacent. So which one should I pick?
Tan.
Tan.
Without a doubt, I should pick tan. Right? So it's going to be tan theta is equal to opposite over adjacent. What is my angle?
48, sir.
Right? So I'm going to put tan 48 degrees,
Mm-hmm.
and that's going to be equal to the
Yeah.
opposite. I don't know what the opposite is. Right? The opposite is AC. Right? AC. Right? And what is the adjacent?
40, sir.
Right. I'm going to write tan 48 degrees as tan 48 degrees over
1.
1. And then I'm going to cross multiply here. If I
So
cross.
tan divided by 2.
Now, guys, what's the unknown here?
AC, sir.
Right. So we should multiply that out first. So it'll be on the left-hand side.
Mhm.
So where's 1 by AC?
AC, sir.
Yes, AC. Right? And somebody else, right? What would that work out to be?
Tan
Hold on.
40. Wait, no, 40, tan 48.
Right. Remember, tan 48 is a number, right? That's a whole thing by itself. So it's 40, right? 40 by that number. So 40 by tan 48, right? So 40 by tan 48 degrees. I'm going to know what you get.
$40 by
40 tan 48.
44.4
I put 14 for Gimas.
5.
You over there. I need new glasses. Yeah. Are you getting 44.42?
Yeah, that's what I got.
Okay, cool. Now here what, keep that answer in mind. Now, guys, when you are doing a multi-step question, should you use rounded off values or the exact value?
Exact.
Yeah, you should use the exact value. Does everybody calculator have the A and S function? The ANS function is right next to the equal sign. Should have it.
Yeah.
Okay, good. So here what, right? Anytime you do a calculation, the previous answer is stored in the calculator automatically under A and S. So if you didn't know, now you know, right?
Wait, I'm not saying a
You have a sharp or a Casio?
sharp.
All right. So, okay, if you have a sharp, you have to press alpha equal. And if you notice, right, I'm not sure if you have the same sharp that I have here, right? But when, okay, above the equal sign to the right, you see like a kind of greenish ANS.
Yes, yeah, I do.
So if you want to get it's color coded, right? So alpha is green, so press alpha, then equal, and you get the previous calculation you just did, right?
Okay.
Yeah. Right. So, guys, everybody got 44.42? Yes or no?
Yeah.
Yeah.
Right. So, again, when we're doing calculations, we are going to use our exact value. You don't want to get rounding off errors. So, here what we're going to do, right? We just found for what? We just found for the what of the triangle.
The bit. The
No,
height, sorry.
the height. So, I'm going to plug that in now. So, I know that the height is 44.42. 44.42. So, guys, do I have all the information now to find the area of the triangle?
Yes.
Yes, sir.
If a question like this come, I had a little more gyro each, yeah? A little gyro each, right? I'm marking it
So
out.
those things are expensive, you know. I don't know if I could get it.
Okay. Well, here what? Come on, half a gyro. Half a gyro. You could
Paris or by the cross.
eat half. I can meet all the by the cross and all the by a gyro.
Mm-hmm.
Or you can pop money and buy one gyro from me. I think like that will work out relatively cheaply. And I have a watch to do the maths too.
Yeah, we could do that, man. We could do that.
Yeah, boy. Right? I love Casio so bad, boy. This is my fourth Casio watch. Big up my girlfriend for this watch. This watch so cool, boy. Hey. Like if I in a restaurant and somebody say, hey, I wonder how we had to split this money, boy. I'll be like, I am him. Pull this out. Bam, 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 boom. Quick maths, quick maths. Not, I mean, I could do it in my head, right? But I mean, not all the time I'll be correct. So, but this ain't real, man. But anyways, it's a half base by height. What is my base? They told us
50
that,
centimeters.
right? They told us that, right? They said length OB was 50. That was the base. Right? And here we're going to do, right? In the calculator, when you're doing this, right? So this is what you're gonna do. Watch carefully, right? So people with the Casio, the Sunway, whatever, and the Quest to watch. So I'm gonna put a half, 1/2, right? Then I'm going to put 50 in brackets, close brackets. Then I'm going to put open bracket, ANS, close bracket, press equal, and you should get the answer. Let me know. Guys, is it working out? Those with a Casio, even those with a sharp, it's not hard calculation to do on a sharp. You just press 0.5 multiplied by 50 multiplied by ANS. Let me know if you
Yes, I get the answer.
okay, those
Yeah, I
are
got it.
the exact value, right? Like 1110. I'll probably say extra one there. 0.612515. Feet. Did you get through?
Yeah, I did.
A word, Dari.
Yes, yes, sir, got you.
All right. Aaron.
So every time I put this in my Casio, it keeps on giving me a fraction.
Press S to D. S to
Yeah,
D.
my
S,
Jackson.
S to
Okay,
D. Pressing it plenty. Seen it? S to D.
yeah, I see it.
You get it?
Just now, sir.
We're not supposed to get a fraction. That's an irrational answer. So something wrong.
Yeah, I get.
Serious?
Yeah, I get now.
The exact thing I have here?
Yeah,
Oh, what kind of fraction was that? That's real weird.
it was telling me, I think it was 221 over 2.
That's weird. That's weird.
How do you type it in a sharp?
All right, let me show you, right? So, question. Did you get this previous answer? Did you get the 44.42 previously?
Yeah, I did.
All right, nice. So in our sharp, just remind me, what's a decimal for a half? A half is the same thing as what? As a decimal? 0. What?
0.5.
Right. So you're gonna put 0.5 multiplied by the base, which is 50, right? Multiplied by now your calculator, right? Tell me if your calculator looks like this. The same one, the same shop.
It looks like that, but it's orange. I had one like that though.
Oh, we don't discriminate. We don't discriminate against color. All right. We just discriminate about shops, not color. Color. Right? So above the equal sign, are you seeing green A and S?
Yes.
Right. So to get that, you're gonna press alpha equal, and that should give you the previous calculation you did. So you're gonna put 0.5 by 50 multiplied, then alpha equal, and then press equal.
Wait, hold on. 0.5 multiplied by 50 by alpha equal. I'm not getting the same answer.
What answer are you guessing?
I get 0.00561, no, 27 and so on.
Wait, let me run this back through one more time. I want you to put 40 tan 48 in the calculator. Put 40.
Tan 48.
Yeah. 40 tan 48. Just make sure you're getting the 44.4 whatever.
40 tan. Yeah.
Right? Okay. All right. Now you're gonna clear the calculator. May not do like just I think with a sharp, you have to press like on/C to clear it. Just like clear this,
Yeah.
right? So clear the screen, right? To make sure that you have the correct thing stored, just press alpha equal. And let me know what you get.
Oh, the same thing.
Okay.
44.42.
You're not getting right? So just clear the screen, right?
Uh-huh.
You're going to put let me show you what you should put in on my screen. 1 second. So you should be putting in this, right? Later. Right. So you should be putting in 0.5, right? Multiplied by 50, multiplied by answer. Press equal and let me know what you get.
Wait. I don't know if that's a point or not, but 11. Wait,
What? What's I gonna?
1,000. Wait,
It's all incorrect. It's all like I say, incorrect answer.
I'm not sure if I have a point here.
That's what you got?
Yeah, I did. Yeah.
That's the correct answer. Right?
My calculator old, so I just have to make sure it's in light so I could see the screen.
Oh, I know what you're talking about. Wait.
Yeah.
Let me show you the sharp that carried me throughout high school. Watch, right there. I gotta see this. It's crazy. I wasn't wealthy enough to afford a Casio. Look at this. It's crazy, right? You see like the
I still have it.
yeah, I still have it. Memory. It's a piece, like a timepiece. So like every time I look at it, right? I just remind myself how far I've come, you know? Yeah.
Oh.
Humble beginnings, sir.
Humble, yeah. I'll always be humble. I can be how big, right? I still gotta be humble. Like I don't I don't see the point in treating people as like they're lesser than you. Because any of you guys could become better in maths than me. I being real. Like the only reason I hear is because I work my tail off in maths. And I understand everything completely. I feel like some people have natural talent for math. I feel like I have some, but not like a crazy amount. I would still struggle with some things. Like I have some people in my degree that just gain like 100 in maths, while I gain 70, 80, 90. Right? I'm just getting 100. It's crazy. And like them just doing
I
nothing.
pass, once they pass, that is it. I don't fight up once I pass.
Yeah, but
For real.
my whole life I've been a perfectionist because I it could sound real bad, but like I've only ever placed second in my entire form once. Yeah. I've
Yeah,
always
but here C's get degrees, and most of the times you end up at the same job,
exactly right, but
making the same amount of money.
oh, it's okay. Yeah, but like I know what you're saying it, but for me, I I I never treated these things as just passing. Like I like these things, right? I like science. So for me, it would just be for the plot. I just be for the plot. I
So
just
you
love
can teach me bio.
I don't like I talking about
No worry.
things with calculations, right? But I don't say that to brag. I just saying that's what you can accomplish if you truly like what you're doing. If you don't like what you're doing, chances are you're gonna suffer, right? Some only hate maths. I'm trying to make it tolerable, but genuinely kind of cool. But yeah. If you want to be the best, you had to find some other reason to be the best than just to be the best. You must have a love for it or something. Cause I real grind. I real work hard. I think anyone could like reach my level of maths for sure. It not hard to accomplish. It just very long and strenuous. But yeah, this is like a 4 or 5 mark question. This could come in our paper 3 or paper 2. How are they feeling with it?
I hope it can, honestly.
I hope so.
And this is in measurements, or is this you?
No, this is I'll just clarify it for you right with the syllabus so you don't have no trust issues. Section 4 is measurements. That would be where you're doing constructions, measurements, finding the area,
Need.
what all that. But I'm doing section 8 right now. Geometry and trigonometry, right?
Okay.
Yeah.
I thought circle theorem was guaranteed to come.
It is. Circle theorem will come. Circle theorem will come.
So that and circle.
Okay. Did you ever do a full exam as yet? Like a full,
Yes.
you would have seen
Yeah.
everything over here. Everything over here would have come. Number theory and
I s-
consumer
uh-huh.
sets, measurements, everything would have
That's
come.
the income because it's paper one.
Oh yeah, yeah. Sets didn't come, right? But everything here came, right?
Yeah.
So yeah, yeah. All right. So guys, are we okay with right angle triangles and area?
Yeah.
Okay. Let me just I want to do one example on the cosine rule and one example on the sine rule, go through bearings and just start a bunch of past paper questions. And then, so like I believe we should finish up by 3 o'clock. At 3 o'clock, give all a break, come back to algebra. Algebra real easy. Like all go mash up that.
Hopefully.
So,
Because guys, we've been
um,
doing algebra. We've been doing algebra this whole time. Everything we do in here is algebra. We've been doing algebra, right? So like, I mean, not gonna be that hard, right? And I'll show you the hacks. And I'll hold the hand and be fine.
So how are you gonna know like if it is just to use SOHCAHTOA or the sine or the cosine? That is the only thing I think I just have problem.
So you're wondering when to use trig ratios or sine and cosine rule, as you're
Yeah,
wondering.
yeah,
Okay, when you say sine and cosine rule, just to clarify, you're talking about these things that like A over sine A is equal to B over sine B is equal to C. You're talking about these things,
yeah.
right? You use sine and cosine rule when you're dealing with a triangle that don't have a 90 degrees in it. I'll say it again. If you see a triangle and it's not a right angle triangle, you have to use sine and cosine. You cannot use Pythagoras theorem or trig ratios. Understand?
Yeah.
So once you do see a 90 degrees in it, sine and cosine.
Okay, so thanks.
No problem. So you will see me writing that over here, right? So non 90-degree angle triangles. Right. So let me do a question one time. Starting off with cosine. For you to use cosine rule, you must have a what? Some of us. You must have a what kind of angle?
included angle.
Right. And when you use cosine rule, you find and for the side opposite the
Opposite the
The angle.
right side opposite. Right, so I'll do a question quickly. So tell me guys, what's that rectangle? What? Somebody in good notes needs to be fired, man. They need to be fired. Somebody needs to lose their job. Bro, I don't know how you could turn a I think the drawing was kind of bad there, but still, geez. Right, let me call this F H K. All right. Let's call this I'm looking kind of big, so maybe 101 degrees. Let's call this 19 kilometers. I'll call this 10 kilometers. Guys, number one rule. Are we seeing an included angle? And if so, what is the included angle?
101.
Does everybody agree or disagree with her?
I agree with that,
I
sir.
agree.
I agree, right?
Listen,
So hear this. If we know that this is the included angle, you'll be finding the length that's opposite the included angle. And I think we should see that, right? Because you know what this is and you know what this is. What's the only missing side?
The hypotenuse.
No. Wait.
Come on,
base.
Well,
H.
no, well,
When we're dealing with
Yeah, come
triangles,
on, H.
right. When we're dealing with triangles that are not 90 degrees, we don't use a naming convention, right? We don't use, I mean, technically, you will still have a hypotenuse here, right? But you wouldn't use opposite adjacent and hypotenuse to describe it. The naming convention is different. So yeah, we will be finding for this. So guys, if this is angle F, what will we call 19 kilometers?
Common F.
Common F.
Right. If this is angle K, what would we call this?
Common K.
Common K.
Common H? Of course,
Common A.
the answer.
Okay.
Let us do that, eh?
Common K.
So guys, hear this, eh? We already figured out that we're gonna find for what? Which side?
Common H.
Common H, right? Common H. So let me show you how the formula gonna look.
Common H.
We're gonna start off with H squared. Now H squared is gonna be equal to what? If anybody knows, you can come and help me, right? But does anybody know what it's gonna look like? The rest of it?
Is equal to K squared
Right?
plus F squared.
Right? Minus.
2.
2KF, sir.
Right? Cosine of the included angle.
101, sir.
Yeah. Well, I'll put H, right? I'll put H. Right. So this is the cosine rule. So it is the side opposite the included angle squared, right? And that's equal to the adjacent side squared plus the adjacent side squared, right? Minus 2, the product of the adjacent side, cos of the included angle. So you probably noticed that we start off with H and we ended off with H. And everything in the middle is just the sides right next to the included angle. Is there anybody that did not understand this at all? At all, at all?
Nah.
No, I think I
I
get it.
understand, sir.
Right. Okay. So let's substitute now. And I only doing one example on this because when we start the past paper questions, trust me, lots of examples. You will not get bored, right? Or maybe you might. I hope not, right? So h squared is going to be equal to k squared. K is 10, so that'll be 10 squared, right? Plus f, f is 19 squared, right? Minus 2, open bracket, k is 10, f is 19. What's the included angle?
101
Right.
degrees.
Yeah, around 1 degrees. So, I'm going to show you how to get the answer one time, right? So I have h squared here. If I have h squared over there and I want to find for h, I'll have to find the what's on the right hand side. The what? Starts with s.
The square root, sir.
Yeah. Because guys, the opposite of squaring something is square rooting something. And you're not seeing the square root here because it would have cancelled off with the square. So it's just h now. Right? So yeah, guys, people with a Casio, you shouldn't have a hard time putting that into your calculator at all. So Faith, you there?
Yeah.
Faith, let's plug it in at the same time, right? So press square root. You with me?
Okay. Yeah, with you.
Then press 10. Then press the x to the power 2 button, x squared. Right? Then
Yeah.
plus 19 squared, x squared button again. Right? Minus 2, open bracket, 10, close bracket, open bracket, 19, close bracket, cos angle is 101, close bracket. Right? Faith, press equal and let me know where you get.
23.0
Faith, see how easy that was? See how easy that was?
Yes.
Imagine if you had a sharp. Oh God. Hey, boy. This calculator is an investment in your future. Right? So H is equal to 23.09, right? The number after 9 is 7, so you'll have to add 1 to 0.09, and that would turn to 0.10. So 23.10. Did that confuse you all? And it's in kilometers.
I'm trying to see if I will get to it.
You have a shop?
Yeah.
If you have a shop, I'm going to show you what you have to do, right? So what you could do, right? You could plug this part into your shop, right? You could plug that part into your shop, yeah?
Mm-hmm.
Right? Remember, your calculator automatically stores your last calculation. So when you plug this into your shop, you could clear the screen, then press the square root button, and then press the NS, and then press equal, and you'll get your answer. That's what you could do if you want.
I think you said it was alpha for the shop.
Yeah, you have to press alpha equal. So people with that shop, if you want to avoid the crazy amounts of brackets, well, I mean, it's not much brackets. It's just one pair extra. But if you want to just do it really simply, so guys, people that shop, follow along here. So you're just gonna plug in 10 squared plus 19 squared, right? Minus 2 open bracket 10, close bracket, open bracket 19, right? Close bracket, then cos 101. Right? Press equal. Let me know what you're getting. Somebody with a shop, let me know what you guys are getting.
2, 10, 19 plus 533.50.
What about the rest of you guys with a
So
shop?
yeah.
Are you getting that?
Yes, sir. That's true.
All right, here what we're going to do, right? Clear the screen, so press on. Then
Mm-hmm.
to press the square root button, right? Then you are going to press alpha equal, and you should get the answer. Come on.
Yeah. Okay, great.
Just help one person.
Okay.
So guys, with a shop, press square root. Then you're gonna press alpha equal. Maybe you might have to press equal another time, but you get the answer. Let me know. People with a shop.
I got it.
I just hearing from like 1 or 2 people. That's concerning.
Okay, so
All right, cool.
Yes, sir.
So let's move on, right? So that's the cosine rule. You use it anytime you have an included angle, right?
So,
Yeah.
on the Casio, is there a button to press where you could like take off a number so that instead of having to start over from the beginning if you make a mistake in your calculation?
Um,
And just delete DEL.
so it's supposed to be able to store your history. With the Casio, you can store your history. But I'm not sure I understand what you're talking about. Say that one more time.
No, so like if you put in an equation you're going to solve and you realize you make a mistake, like you put the wrong number, is there a button to just take out that number alone instead of having to start over from the beginning?
Yeah, delete.
Oh.
Yeah, DEL.
So like if I put in 5x squared plus 6, right? Watch. Plus 9y. Let me just say, I'll put this in, right?
Yeah, sir.
Here it is 6. I go to the 6, right? Delete it. And I'm putting whatever I want.
Okay, sir.
Yeah. And just a humble reminder, your Casio could solve this entire thing for you if you put alpha, close bracket, squared, right? And then you press equals to 10 squared plus 19 squared minus 2 by 10, open bracket, 19, close bracket, cos 101, close bracket. Then you press shift calc, then press equal. Yeah, your Casio is gonna solve the entire thing for you. Faith, your calculator can do this, eh? People with the quad whoever and the sun way,
Yeah.
or the calculator can do this. It's pretty crazy. Yeah. People with a sharp. If all they're gonna pursue higher level maths, get rid of the sharp. You're gonna real hold it back. Right? And even if like, okay, you don't have an excuse there, because maybe you might say, well, sir, Casio expensive. You can get a knockoff Casio for $110, right? Which is cheaper than the shop. Guys, get rid of that shop. One that. So we okay with the Cas? I love Casio so much. I'm gonna say Casio rule. I should have new watch. They like it. If he's how proud my girlfriend is. Yeah, everybody okay with the cosine rule? Yeah, no, maybe.
Yeah, sir.
All right. Sine rule. So I'm gonna take the same question, all right? The same question, and what we're gonna do. Same question. Guys, a simple thing, right? A simple thing I was taking this 19 and putting it over here instead. Can I use the cosine rule now? Or nah?
No.
No. Because it's 101 degrees I included angle. Like as it is right now, is it time?
Nah, it not.
It not, because you don't know what this length is, right? So guys, in this situation, right?
No, because it's not next to.
Exactly. And in this question, I'm going to ask you to find for angle key. By the way, guys, I'll just follow disclaimer, right? Anytime they ask you to find for an angle, anytime you are required to find for an angle, please keep in mind that you'll have to use the inverse trig functions. Inverse trig functions. And if you're confused by the fancy mathematical jargon, I'm just talking about sine inverse, right? I'm talking about cos inverse, talking about tan inverse. So I hope nobody's confused. So find for F key H, right? If you are confused by this notation, right, watch F key H. The angle is in the middle. So we could see is by key. We could see is by key, right? So FKH, angle in the middle. So guys, what would the sine rule for this look like? Tell me, what would the sine rule for this question look like? The general one, with all three letters. Maybe I could start you all off. Maybe common F all over.
Sine
sir.
F
Tell me common or capital, eh? Tell me common.
equals common
With
K over
common K
sine capital
over
K
sine capital K.
equals common H over sine capital H.
Right. Now, guys, remember how we selecting this, right? You're looking for a pair. You're looking for a pair, right? And you're looking for the unknown. Do we have a pair of information anywhere over here? Or let's see up here.
Yeah,
Yeah,
H.
You'll agree that each is a pair of information.
yeah, sir.
Okay, Dari, do you know why we're saying that each is a pair?
So because that's where the angle is.
No, not just that. Where's angle H?
101.
And do we have length H?
Length H?
Yeah.
Yeah.
So my question is, do we have the angle and the length for H?
Yeah.
Yeah, that makes it a pair, right? Bam.
Yeah.
Would you say that you have a pair of information for key? Do we know what angle K is? Are you seeing anything there?
No.
So
No,
No,
sir.
that would not be a pair, right? That's actually an unknown. So guys, tell me, what two am I going to select? Which one am I selecting for sure? So, which one is it?
The 19 and the 101.
Right, so
A and H.
I'm definitely selecting H because I have a pair here. I have a pair, right? And what is my unknown? Dari, what am I trying to find for in this question? They want me to find for FKH. What angle is that? That's angle what?
K.
Yeah, that's angle K.
Yeah.
So we automatically have to select.
H.
No, we select each already, right?
Mm-hmm.
But you're selecting the pair and you're selecting the unknown.
Unknown.
So what are we trying to find for? You just
K.
K. So which one are we going to select? F or K?
F.
No. Again, we selecting the pair and we selecting the unknown.
Unknown. Oh, so it's F and K. Yeah.
No, not F and K. Not F and K. Let me ask that question. Which one was the pair of information? Remember, for it to be a pair of information, you must have the angle and the corresponding length. So if you tell me F, right? If you said F, tell me, do we even know what angle F is? Are you seeing an angle here?
Yeah.
Okay, what angle is you seeing there? That's the question.
No, it's an angle there.
Right.
Yeah, yeah.
Right? And are we seeing a length for F?
Yeah, but there's no length.
I don't have a length, right? So
No.
can I even use F? Do I have any information for F?
No.
No, so I can't use F. Or
No.
right? Do I have angle H?
Yeah.
Do I have length H?
Yeah.
If you have a pair like that, you select that one, select H one time.
Pair
Right?
and unknown, yeah.
And you're trying to find the key, right? That's what they want me to look for. So you have to select that two one time. Don't stick. That's how you know which two to select, in case you was wondering. So you have it now, right? You're selecting the pair and we're trying to find for. So our formula we're going to use is K over sine K. Right? And that would be equal to H all over sine H. So guys, what is key? What is key?
10.
K is 10, right? What is angle key? Do we know what angle key is, or we're trying to find for that?
We're trying to find for that.
Trying to find.
So I'm gonna leave that blank because I don't know what that is. Right? Don't do that with your maths exam, eh? Guys, don't do that with your maths exam. Don't be like, I don't know what this is, so I leave it blank. Don't do that. I'm looking at you, you know. Someone just said illegal. Don't do that, eh? It's H. What is the length H?
19, sir.
Yeah, 19. What is angle H?
101, sir.
Right. You're seeing how much fractions on either side? Yeah, one fraction on either side. All right. So anytime you have a fraction on either side, what to do?
Cross multiply.
Right. What is my unknown?
Sine K, sir.
So I want to multiply that first, right? Right? I want to multiply that first. So it'll be on the left-hand side. That confuse you, understand what I'm saying?
No, I understand, sir.
So we're going to multiply this out first. So Dari, just to make sure you understand this thing, tell me, if I multiply that, what am I going to write here?
$19 sine K.
Ah, boy. Yes, man. Yeah,
Yeah.
boy. Right, 19 sine K.
Yeah.
Right, and somebody tell me, what that'll be? Probably. What that'll be?
10 sine 101, sir.
Yeah. Now, this is going to look a little complicated, but you all could figure this out. It's not hard. We are trying to find for the angle. So remember what I said, anytime you're trying to find for angle, expect to use the inverse trig functions. What is the trig function I'm working with here?
Sine, sir.
So most likely we'll have to use sine inverse. But before we could do that, we have to find for sine k, right? Sine k is currently being multiplied by what?
19.
Right. So again, here this, guys. Before you could find for sine inverse, you need to find for sine k. Sine k is being multiplied by 19. So you're going to divide by 19 on both sides. So that would cancel off to leave you with sine k. Am I confusing you all? Or like you understand what I'm saying?
Understand, sir.
Understand.
All right, Adika, you good? Or nah? Adika?
Say again, repeat.
Adika, are you confused? Are you okay?
Oh, no, sir. I understand.
All right, so Faith, you're gonna see how clutch that Casio calculator is gonna come in. I know it's not a Casio, but it's basically a Casio. I'm gonna call it a Casio, right?
Yeah.
It identifies as a Casio, right? So sine k now is equal to 10 sine 101 all over 90. So guys, if I want to find the k, I'll need to apply the what?
Sine inverse.
Yes, I'll need to apply sine inverse. So it's going to be sine inverse of this entire thing. Now, peeps, if you have, don't worry, sharp users, I'll show you how to get the answer, right? Don't worry. But for Casio users, this is so easy, it's crazy. So Faith, I run through this together, right? Perseus, you still there? Perseus, I'm gonna feel okay.
Yeah, so it's just mindful. I'm being kind of sleepy.
All right, well, I'm gonna call a little more then. Faith, try to plug it in the calculator in the meantime. So Perseus, I want you to start off by pressing Shift Sine. And let me know if you get any sine inverse.
Yes, sir.
Then you're going to press the fraction button.
Did that, sir.
Then you're going to put 10 sine 101 and close off the bracket.
Yes, sir.
Then you're going to press the right arrow to go into the denominator and then press 90.
Did it already, sir.
Then you press the right arrow to come out, then close the bracket, press equal, I'm going to away again.
$31.1075.
See how
31.11.
See how fast you get an answer? Imagine if it was a sharp. Just imagine that. Just imagine that.
Sir, you shop biggest hit, I know.
I just saying, like you know how to walk and sharp users, don't worry, I will show you what to do, right? But like,
So I kind of feel as the shop will make me feel sexy, you know, because I didn't even know how to use that calculator, to be honest.
I feel so. But let me not put the entirety of
Degrees?
one shot, right? Yeah, degrees, because we find an angle. Unless you do not add maths and you know about radians. Right? So K would be equal to 31.11, right? 31.11, if I round it off to two decimal places, degrees. Right, so sharp users. Let me show you what you're going to do, right? If you have a sharp, this is what you're going to do. So first things first, you're going to put 10 sine 101, close bracket, divided by 19. Right, people with a sharp, just verify that you're getting 0.516645886. People with a sharp, verify this for me.
Yes, sir. Got you.
Okay, yeah? Anybody else? Anybody else can verify that they got the 0.51 on now.
Yeah, I got it.
Okay. Next thing, I'm going to clear your screen to press on.
Mm-hmm.
Then you are going to press second function sine. And you should see sine to the power minus 1. Then you're going to press alpha equal to recall the previous answer your calculator would have stored. And let me know if it works out.
Yeah, just now. Second.
So you can repeat back.
Oh, yeah, the power bracket. Just now.
Yeah. So, Dari, I said I had, after you get the answer, you got to press second function, sine. And sine to the power minus 1 should pop up. Right?
Yeah, get you.
Yeah.
Okay. People will be shocked. Did you all get to the 1.11 when you're on the sub?
Mm-hmm.
Yeah.
Oh, great. Nice. So guys, we okay with this, right? Sine and cosine?
Yeah, sir.
Alright.
Yes, sir.
So guys,
Yes.
now we just need to look at bearings, right? And we had to look at depression and elevation, and that'll be for trigonometry. Just do a bunch of past paper questions. So just to give all you a crash course on bearings. Bearings is literally just directions. So like how would you go from one place to another place? Like let me show you how like this is crazy easy. Do you all know about the cardinal points? Yes or no?
Yes,
Yes,
sir.
sir.
Okay. Oh, and if you just have a hard time remembering this, just remember it like N we S, right? You will never forget it again. N we S. I actually learned that from a student, right? He told me that, and I was like, what? I didn't know that, right? N we S. Now, guys, check this, right? Let's just say, Dari, let me just say you over here, right? This is you.
Mm-hmm.
Oh, God, I draw you with a big head. Sorry. Right, smaller, right? Yeah, so this is Dari. And let me just say I over here, right? Wait, I actually have a big head, so wait, right. So Dari,
Yeah.
from where you are, you would say that I am in a what direction? North, south, east, or west direction?
Note.
Exactly, right? That makes sense.
Yeah.
That
Yeah.
makes sense, right?
Some people might say east as to like watching it according to the direction.
Nah.
Yeah.
That's not. That's not. I
Yeah.
not.
Yes, I know. Yeah.
Yeah, that's not for sure. Right? Let's see now, right? Like I am located north of where Dari is. That makes sense?
Yep.
Okay, so waiter. This is geography vibes. I'm teaching all you geography here. Geography vibes. Geography. My plan is to eventually teach all the science subjects, but like, taking it one step at a time, right? One step at a time. So, Dari, we would say that there's a bearing of 0 degrees. That's what I would say. And if you're confused, Dari, I want you to think of the north line as 0 degrees, right? Think of the north line as 0 degrees, yeah?
Yeah.
Okay, cool. So, this would be a bearing. So this would be a bearing of 0 degrees, right? Okay. What now? What if I now move over here? You would say that Rajiv is what to you is to the north of you, to the west of you, to the east of you. What would you say? Kalmadari. You would say that Rajiv is to the what of you?
East.
East. And in maths and geography, that would correspond to a bearing
as not, or
90 because you,
Why isn't it south
I
if
was
it's
gonna
three
say,
bottom?
okay, watch.
yeah,
If I moved over here, right, then I would be located south of Dari, right? If I am over here,
Okay.
I would be
East.
east of Dari, right? If I am over here,
Okay.
I will be
so
west.
it would southeast.
Say that again.
It wouldn't be southeast.
We're not being extremely specific. This is like a big, a general idea, right? But
Okay.
southeast would be like over here. That would be southeast. But I was saying over here, like directly in line with him. Directly in line. If it's directly in line with him, can you see that's in an eastern direction?
Yeah.
All right. And over here now, this would be in a what direction?
A western direction.
Right? And over here,
Northern direction.
so here what I'm saying, right? Bearings
Yeah.
actually measured from the north line. So I would say, like, if I am located over there and I'm north of Dari, then the bearing of him to me is 0 degrees, right? If now I move here, if I move over there, right? I'm now in an eastern direction from him. Can we see that? Yes or no?
Yes.
Now,
Yes.
now, guys, if I moved in the eastern direction, I would have moved how much degrees?
90 degrees.
90.
Right. So that would be a bearing of 90 degrees. So from Dari to me is actually a bearing of 90 degrees. So bearings is just directions. I don't know why teachers just make it complicated. It's literally just directions, right? Like how would I go from one person to another person? Like what would I follow? That's literally it, right? And okay, if I come over there, right? If I come over here, Dari, I would be what direction from you?
South.
Okay, Dari, if I move from north to south,
Mm-hmm.
where is that? How much degrees is that?
90.
Nah.
No, 180. 180.
So the bearing from you to me is 180 degrees,
Right.
right? If I come over here now, I would now be, right? I'll be west of you. So that bearing would actually be how much degrees?
270.
Yeah, 270. I don't understand any concept of bearings. It's just directions,
Yeah.
right? So we're gonna get a little more technical with it. So guys, you would have seen me measuring the angle from the north line in our direction. This is clockwise or anti-clockwise?
Clockwise.
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 Right. So generally speaking, when you're doing bearings, right, you are starting from the north line. So from the north line, and you're going in what direction?
Clockwise direction.
Clockwise direction.
Clockwise direction. And anytime you see the word from, that is where you're gonna put down the north line. That's where Santa Claus living. Right. I feel like my jokes is just fly over all your head like Santa Claus in his sleep. That was funny. That was funny. If you want to hear about that, I'd have him up. But anyways. So, all right. So, Dari, let's just say you're over here, right? So,
Wait.
yeah.
All right,
Mm-hmm.
All right. So, Dari, let me just say that this is you over here, right? So, I'm gonna put on a question. Find the bearing. Find the bearing from Dari to Rajiv. Right? So like as soon as I have that copy down, let me know. Jumping straight into action. And then past paper questions like we outside, we have it.
I finished.
All right. So find the bearing from Dari to Rajiv. So immediately, okay, I'm gonna put down Dari over here, right? Dari, this is you here, right? 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 And this is me.
Mm-hmm.
The first thing I want you to do is I want you to connect you to me. I'm gonna connect those points together. Right? I'm gonna connect those points together. Second of all, where is it from? It's from where? According to the question, it's from where?
From Dari to retrieve.
So from Dari. So you know what I'm gonna do? I'm going to pull on my note line by who? Who am I gonna
By
put?
Dari.
Exactly. By Dari. Right? Right? And geography students. I look like what direction? Like a north, what direction?
Notice.
Northeast.
Yeah, yeah.
I
But
gotta do the geography too.
but we go into right, it's in terms of our bearing, right? By the way, guys, what do you think is the maximum the bearing could be?
360.
180.
360.
360
Oh.
degrees.
60, guys. If you take 360 degrees, you're gonna end up back where you started, so that wouldn't make sense, right? So
Oh.
360
So it
is
could be 180.
180, sir.
360.
Oh.
Oh,
Because what shape is this?
a circle.
Circle.
Sum of angles in our circle is
What?
the sum of angles in our circle is what?
360.
360.
Right. So the maximum bearing is 360. Right?
Yeah.
So here what? People who have trouble with measurements, let's give this a go, right? So sometimes they might ask you to measure the bearing with your protractor. So we need to be able to do that for sure. So guys, who here would have trouble measuring this with a protractor? Be honest.
Me.
All right, so here we're gonna do, right? You see the line connecting Dari to Rajiv? See that line? It's the blue line. See the blue line, right?
Yeah, I see it.
And you see the red line. All right, so here what we're gonna do. We're gonna take our protractor, we're gonna rotate it, and remind me, where do we start from? When you measure in bearing, you start from the what? Start from the
Notes.
Notes.
start from the north line and you go in what direction?
Clockwise.
Clockwise, right? So here what we're gonna do. If we are starting from the north line itself, I need you to take your protractor and line it up with the north line because that's where we're starting from as a reference point. Right? So that's what we're gonna do. Right? So this is 0 degrees over here. A little bit more or now? Let me know.
Yeah.
Right? So 0
Yeah.
in a clockwise direction, eh? So how much degrees are looking like?
60. 62.
I go.
No,
58.
59.
That looking
59.
like 59 if you ask me. Looking like 59. Watch. Right? Looking like 59.
Yeah, 59.
All right. So guys, are you looking on some bearings a little better?
Yeah.
Yes, sir.
I really use the bearings, you know, really how much for bearings? Right? I will explain some other tricks to you that I need to know. Right? So we said I was 59 and yeah.
Yeah.
Now let me show you something. The other type of question they would ask is this. So the next part might be like, oh, and let me just blow some all your mind, right? I'm gonna blow some all your mind. Or you're gonna be like, what the jail? Anybody show me this? So Dari, the bearing is 59 degrees, hence.
Yeah.
So, Dari, watch this, right? Let's just say that this black line here is you holding a compass. And this is the compass telling you to go in. So the compass telling you to go in this direction. I tell you, somebody in good notes needs to be fired. Like this, it was so good, and then I don't know what they do. Like it just it's infuriating. It just make me feel to go into shooting mode. I don't know what's wrong with these people. But anyways, all right. All right, so Dari, can you see that this is a 59 degrees here?
Yeah, yes, sir.
So guys, watch this, right? So this is Dari over here. He wants to go by Rajiv to learn some maths and pass his exams and subscribe to his YouTube channel. Big up Dari one time. So Dari, if you leave by you and they continue in this direction, Oja, eventually we're gonna end up at
Rajiv? No, but
yeah, you're going to end up at Rajiv. If I write a bit more accurately, like this could be you over here.
Right.
Right, watch.
Okay. Yeah.
Yeah. You understand?
Yeah.
Yeah. So the other type of question they will ask you is find the bearing from Rajiv to Dari. Let me just say, yeah, you come by but now you want to go back home. All right, so you need to know the bearing. So check this out, right? In this particular question now, where is it from? It's from where? It's from where?
Rajiv.
Right? So you know what I'm gonna do? I'm gonna put on a note line by who?
Rajiv.
Right. I'm gonna put on a note line over here. And guys, is that legal? Is that legal?
No, it's just the opposite.
No,
because we take bearings in our direction.
Clockwise.
Yeah, not clockwise. Now, guys, who here would have a hard time measuring this angle with a compass? I mean, a protractor. Be honest. Who would have a hard time measuring that with a protractor?
Me.
Okay. Peter, let's tell them this. So I can go it over. Watch this, right? And you're saying that, because this angle, this bearing looking like it's more than 180 ends. It looking like it's more than 180. That's why you're saying that ends.
Yeah.
All right. So let me show you what we're gonna do here, right? First things first, right? What is this angle over here?
180 degrees.
Okay, does everybody agree that
180 degrees?
Yeah, 180.
Okay, so guys, I want to let you know we already have this covered, right? It's 180 degrees. We know that for sure. So the
Yes.
piece that we actually need to find for is this piece over here. And then what we're gonna do when I find for that piece? To figure out the whole thing.
Subtracted from 180.
Yeah, it's subtracting that from 360 degrees.
Nah. Guys, if this is 180, right? So hear this. We want to figure out this entire thing, right? That entire thing. And we just said that this whole thing over here is 180.
Yes.
Yes, sir.
Right. But the full thing is actually a little past 180, yeah? And this past 180.
Yes, sir.
Yes.
We would need to find this small angle, right? Whatever it is, and add it to 180. That would tell us the full thing. That confusing, all you understand.
Nah, I understand myself.
I'm not sure where they get our minus from, but that's fine. We learning. It's cool.
No, but how are we gonna find the missing angle then?
The angle we want to find is this angle, the bearing. Remind me, when you measure in bearing, measure bearings in one direction.
Clockwise.
Asking feet.
Oh, sorry.
No, wait. So I'm going to add 180 plus the 59, since we already have that answer.
Yeah. That brings
And then
really
That
nice.
answer, I'm taking that away from the 360.
Right. Yeah. But you see, the question will never ask you to directly find for this, right? This is not the bearing. This is not the bearing. That's not the bearing. This is the bearing. That's what the question will ask you to find. Because the bearing is always, right, in a clockwise direction from the north line. So it has to be in this direction. There's no real purpose to find for this. But I will show you guys all the different ways you can answer this question. So let me blow some of your minds, right? If I draw this properly, it's supposed to work out. Let me see. I want somebody to measure the angle for me. Measure this angle for me.
52. No, wait. 57.
Now, if I drew it perfectly, it's supposed to be 59.
Oh.
If I drew it perfectly, it's supposed to be 59.
Oh, wait, I seen it. Yeah, no, man.
And let me explain why. Do you all know about alternating angles? Yes or no?
Yes, sir.
Okay, if you don't know about alternating angles, that's fine. I'm going to just give a quick rundown on alternating angles. Anytime you have two parallel lines, meaning that they both going in the same direction, so they would never intersect, right? And you have a slant line through the diagonal lines, the angle on the inside is actually equal to the angle on the outside, right? And the same thing over here. That angle over there would be equal to this angle over here. So you're probably wondering, well, how I see that in the diagram? Well, I'll show you. Just keep this in mind, right? Keep that in mind. It works whenever you have two parallel lines. So my question to you guys is, are any north lines parallel to each other? Yes or no? Wait, you're not seeing your screen?
Yes.
Yeah, it is.
Yeah.
Last second. Let's share back my screen there. Are you all seeing the screen, right?
Yeah.
Can we all see that the north lines are parallel to each other?
Yes.
Can we see a slant line over here?
Yes.
So this angle and this angle are the same. Conversely, you will see that this angle over here and this angle over here is the
Same.
yeah. So that's alternating angles for you. But I was just showing you all how to measure it with the protractor. So if you have a protractor and they ask you to measure this bearing at the start, as the first thing they're asking you, I want you to know that this angle over here is how much degrees? How much degrees is that at one time?
180.
Right, that's 180. So we know that. Cool. But let me ask you that question. Does our protractor measure more than 180 degrees?
No.
No, it does not. So what you will have to do is you'll have to keep in mind that this is 180. And if you want to go all the way over here, you'll have to go some extra. So you'll have to take your protractor and line it up like this and measure the extra angle. And then when you get the extra angle, what are you going to do to it? Add it to what?
180.
180.
Yes. So my full bearing will be 180 plus 59. What is 180 plus 59?
180 plus
59.
That should be 239, I think.
Yes, sir.
Right.
Yes, 239.
I'm blow all your mind in another way, right? Watch this. There's another hack you could know. You could keep in mind. Right? Check this out. So, I show my students this. I want you to think of this as a straight line, right? What is the sum of angles in a straight line?
180 degrees.
Right, 180 degrees, right? Let's check this. Guys, and all of us could agree. Want to find the red angle over there? Like this red angle? Yeah or no? This red angle. And isn't that the bearing? Isn't that the
Yes,
bearing?
sir. Yes, sir.
You want to figure that out. So check this, right? I'm saying that the sum of angles about a line is 180. So if this is 59, what should this be?
180 minus 59.
What is 180 minus 59?
121.
121. All right. And guys, what kind of shape is this?
Circle.
A circle. So if this is 121 degrees and the full thing is 360, how do you think we're going to figure this out?
360 minus 121.
Yeah. What's 360 minus 121?
239.
Maths is kind of crazy, right? You get it 239, yeah?
Yes, I was actually working it out.
Nice. Yes, there are multiple ways you could go about the same thing, right? But I think you will most likely use this in the exam. So let me just go through the hint, right, or the hack. The question asks us to find the bearing from Rajiv to Dari. So how would I go from Rajiv to Dari, right? So guys, anytime you see the word from, that means you're going to put down the note line at that point. Yeah? Do we all agree with that? Wherever you see the word from, you're going to put down the
Yes,
note.
sir.
I only hear some people.
That's it.
Wherever you see the word from, put in that note line down there. Let me hear the rest of you guys now. Like, it did bothering me, like, stops, like, oh, unmute and say vibes or something, or one if you understand. I don't know.
Vibes.
Vibes.
Okay. So, we agreed that the bearing would have been a red line, a red angle over there. Because you had to start from the note line and go in a clockwise direction until you touch the line connecting Darius to Rajiv. Dari to Rajiv. Dari, what's your full name? I don't think Dari is your full name, is it?
No,
What's your full name?
my government name.
Your first name.
My full name Durham.
What is this?
Durham.
Daram?
Yeah.
Okay. I was gonna give him his full government name there, boy.
No, I wasn't hesitating. I
After
wasn't
that,
hesitating.
asking somebody, is your ops here? You know, boy.
No, not here.
Right. So here I was saying, right? We want to figure out the right angle. Now remind me, that's our what?
A circle.
Was he summer angles in a circle?
360.
360. Oh my God.
60, right? And I said that the sum of angles in a line is
180.
180.
right. So if this is 59, wouldn't this just be 180 minus 59?
Yes, sir.
Right. So is anybody confused as to how I got the 121?
No, sir.
All right,
No,
then. All
sir.
right, then. Hold on.
No. And if this is 121 and this is 360, how would I figure out for this?
By minus and 360 by 121.
That's all. So now, here what? I feel like now we could go into past paper questions. I just had to cover angles at elevation and depression, but we finished trigonometry. How will it feeling about bearings now?
Good, sir.
So all they understand
Easy.
that bearings is literally just directions, right? Like, okay, watch this. Watch this, right? If I were to draw mute my big head, right? Waiter. Put your brain over here. Big brain energy, right? Right? So we agreed that the bearing is 239, right? And that was the bearing we agreed upon.
Yes, sir.
So watch this, right? Check this. If Rajiv takes this bearing, right? He takes this bearing. Where will he eventually end up at? Wait. By who?
Oh, by
Dari.
Dari.
Yeah. Right? Yeah. So yeah, maths is kind of cool. It's the foundation of all the other subjects. And geo students, you will see that this is in our direction, north, south, west, east.
Uh, northwest.
Now watch.
Southwest.
Southwest.
Yeah, southwest.
Oh, okay.
Southwest. So I'll put it in some geography here too, because I think you have to do bearings in geography too. But like from my
Yeah. Yeah.
like from my
Um,
research, the geography teachers can't teach us at all. Like when
no.
I was in secondary school, boy, oh god,
And it has 16 cardinal points.
boy,
Yeah.
you know about no 16 cardinal points something. I know about again, I don't teach geography. I know about northeast, northwest. I know about like north, northeast, south, southeast.
Yeah. That would make like 16, I think.
Boy,
Yeah.
I would just find the bearing and done. Right? I would just find the bearing.
This is all for bearings.
Yeah. But here the cool thing, right? Here the cool thing. If you have a compass, right? If you have a compass, if you measure 239 degrees on your compass
Yeah.
and you just keep walking blindly, you'll eventually end up by Dari. It's crazy. It's crazy. I know it's crazy. Right? Because the bearings just tell you the directions to go in. That's all. Yeah. All right. So let me know when we're ready to move on. We just had a look at
It's not right.
depression. Depression. Look at some depression. Yeah, depression. And then we're gonna look at elevation. And that is it. So the badness has go. And that topic completed.
Elevated.
Yeah. Algebra gonna be cake.
For you.
No, for all year, right? For all year. I will make it easy, I promise. Promise.
Okay, go ahead.
Right. I really want to know what you think we was doing the whole time. Like, and all of this is algebra, you know. All of this is algebra.
Yeah, but I doesn't remember which one to use because it just have simplifying expressions and then I can't remember the other two. Hold on.
Shannon thing. Yeah, they are like greatest common factor. Yeah,
Factorization and simultaneous equations and quadratic equation, all them type of I don't like that.
understand. Understand. Right. So, depression. Right, don't look around thing here. So angles, depression. Guys, when you're depressed, you're feeling up or down,
Down.
right? So watch this. I'm gonna draw a building over here. Draw a building. Right? And I'm gonna put me on top. Right? And he might jump. Might jump. Right? His fate is in your hands. Just saying that. So guys, let me explain something, right? If you have your eyes directly in front of you, that's going to create a line of sight. Do you understand what I'm saying? Like if you look straight ahead, that'll create a line of sight. Yeah? Yeah or no?
Yes, sir.
Okay. Now, let's just say that I look down at the ground, at something on the ground, right? Can we see that an angle is being formed here?
Yes, sir.
Right, so angular depression is just the angle that's formed by looking down at something. And alternating angles comes into play over here as well. Like watch this. Right? If I say, what, can we see alternating angles? Let me know.
Yes.
So the angle over here would be equal to the angle over here. That's the main thing you need to know when dealing with angles of depression and elevation. Right? So, yeah, I'll understand this. And from here, you can apply your trig ratios or your Pythagoras theorem, whatever it may be. Let me know if you guys understand this.
Yes, sir.
So here what
Yes, sir.
I'm saying, if you're looking directly ahead, call a line of sight. Let me just see it real fast. You see somebody getting cussed on the ground, right? You say, bacchanal, bacchanal. So you're gonna look at the bacchanal, right? That would create an angle, right? When you move your eyes, that would create an angle. And that angle it would create would be equivalent to the angle, right, between where you're looking at and the ground. And from there, you should be able to apply your Pythagoras theorem on your trig ratios and what have you. So that's angular depression, right? Please don't make me jump off. I don't want to jump off. I know all I could do it. All I could do it, sense. I'll not give him any reason not to jump. I had to say, yes, man, I could pass this exam, boy. This exam is, I can get 2 or 1, man. Darius, you gonna let me jump, boy? Wait, boy, Darius, boy. Nah, boy. Wait.
And distinction. Say, I don't go buzz, sir.
Right? Wait. Oh, right. This is how I'm feeling right now. You're not really hyping more. So I don't know if I'll gonna pass or not. Faith, you feel like you might pass?
I'm
Damn.
gonna say yes.
Okay, at least a 3 or something now. At least. But like, I'm gonna manifest all that. Look at 2 or 1. Right? Yeah, so Faith, let me just say somebody over here, right? Let me just say I still over there, right? And I closer to the edge. I closer to the edge. Things real bad. Let me just say this is you over here, right? Yes, I'm here, right? So Faith, if you are just looking directly ahead, right? If you're looking directly ahead, you will see the building, yeah?
Yeah.
And let's just say you see this crazy man about to jump, aka me, and you look up at me, right? So
Mm-hmm.
when you move your eyes, it's gonna create a what?
Angle. An
The
angle.
angle.
Yeah. And I mean, I guess you could see from a right angle triangle, you have an angle. You can see how the badnesses go, right? From there, you could figure out this length because you would have a triangle, a right angle triangle. Make sense?
Yeah.
Right, so we're officially done with trigonometry. Let's go. Let's go. Are you ready to start past paper questions now? Mash it up.
Yes, sir.
Yeah.
Sir.
Yeah. Talk to me. Yeah, talk to me.
So I just have one unrelated question.
Sure.
By chance, you just teach pure maths?
Yeah, but like I don't have the time right now. I want to do some lives on YouTube videos. But like my engineering degree is stressing me out. Real stressing me out.
All right.
Yeah. If I wasn't,
Because I have to write CAPE in May, June.
oh, okay. So you're doing pure maths right now?
Well, I haven't started.
Oh, okay. All right. Don't know how that'll go. When that bridge come across that bridge. But like once it's maths, I could probably help you.
I'll wait until I finish maths in January.
All right, good. Well, you seem like a quick learner. Because I remember when you started versus now, seems like you could fight your own battles now, so to speak. Yeah. So Faith, give me a year. And then we start. Give me a year. I guess then you're gonna say January 2025, and I wasn't gonna say that.
I'll say 2022. Yeah.
Okay.
No, 2022.
So presumably in January. All right. Get to this question already. If you was there in my lives, I would did this question already. All right. So Faith, get the question I read from her. Okay, you can figure out all of this, right? This just they already put everything in the diagram. It's fine. So what do we to do in part one? I didn't hear.
I see angle in the middle, which is L.
Right. No, this is what I
I
studied.
said calculate angle MLN, which
Right.
is the angle in the middle, L.
Right here, right? Yeah, right here. Because what? M, L, N. So right here. Some of you understand now.
Yeah.
All right. Is there anybody that's confused? Like they say MLN, right? So M, L,
Yeah.
N. Can we see that the angle will be the angle in the middle here? Yes or no?
Yes, sir.
Yeah.
Guys, what triangle should we be looking at?
Yes.
Like which triangle? Which triangle should we be zoning in on?
MLN.
Yeah, MLN, right? MLN. So
LMN.
yeah, I'm gonna draw that separately, right? So this is 88 degrees. So I have a question, right? Are they seeing any included angles? How much marks is that? 3 marks question. Guys. Let me tell you, what's the x equals 0, right? Anytime you see a 3 mark question, right, you either how to use cosine, right, or you how to use sine, right? Anytime they ask you for a length, it's typically cosine, 100% of the time. Anytime they ask you for an angle, it's sine. And this is like gold. Remember this. So, Oliver, since you're asking us for an angle, what do you think they're going to make we use? Sine or cosine?
Sine.
Sine, yeah. L, M, N. This is 12 kilometers. This is 10 kilometers. And we need to figure out for this angle over here. Are you with me so far? Like, I don't know if anybody confused.
Now, I understand.
Okay, what about the rest of you guys? Do you all understand why I decided to pick this triangle? Or no? No.
I feel confusing.
All right, talk to me. Tell me what confusing you.
All right, so I know see it. I know see the question.
Okay. The way to find MLN, right? MLN. So MLN. That's this angle over here. Now I said, anytime you see a 3 mark question, mentally prepare yourself for a cosine or a sine rule question, right? Cosine means length, sine means angle. That's typically what they will ask you.
Okay.
Question, guys. So we just stay on meeting. Let's do the question together one time. If this is angle L, what would I call this?
Come on, L.
If this is angle M, what would I call this?
Come on, M.
If I have angle N, what would I call this?
Come on,
Come on,
M.
So I want you to write the full formula for me with only 3 expressions. So common L all over. That's not a new one. common L over sine what?
Sine capital L
Right? Equals to
equal to common M over sine capital B equal to common N over sine capital N.
all right. Now remember how we're gonna choose the two, right? You're looking for a pair, right? And you're looking for the unknown, which is what you're trying to find for, right? So let me ask you a question. Are you seeing any one of them that has like an angle and its corresponding length? Wait, Darius.
Yeah.
Darius is
Yes,
on.
sir.
I don't
Yeah.
see that boy. Are you seeing any background, boy? Hey, boy. Darius URL birds, boy.
That's a new one.
A new one? Hey, you friendly?
Yeah, he team.
He probably watching the maths. Right now, he looking like angular depression. He looking like he just there looking down, thinking about some things. Hey, boy. As he window,
Yeah.
what if you like jump out?
Nah, he just not bad, so he taking in the sun.
Oh, okay. Yeah, guys. L, M, and N. Which one do we have a complete set of information for?
M.
M, right? I think everybody could see that we have angle M, yeah, and we have a length M. So Dari, and you have a hard time with this, but you get in there, right? So Dari, immediately you're gonna choose M. Why? Because we have the angle and we have the length.
Yeah.
So immediately you're gonna put a little tick by that. And what are we trying to find for? What is the unknown?
L.
L. So I'm gonna select
Yeah.
that as well. So I'm going to use L all over sine L is equal to M all over sine M. Right? Tell me, what is length L?
10.
What is angle L?
12.
Well, nah,
Mm-hmm.
nah. Mm-mm.
Oh, son. Right.
So you don't know what that is, eh? You don't know what that is. So I'm gonna leave that as capital.
You said M or N?
I said L.
Oh, never.
Yeah. What is length M? Come on, M. What is common M?
12. 12. Yeah.
Right? What is angle M? Angle M.
Huh?
Angle M.
M?
Yeah.
88 degrees.
Right? Nice.
Yeah.
So guys, we have a fraction on either side. So what should we do here at this stage?
Cross multiply, sir.
Right, we should cross multiply.
Multiply.
So what is the unknown here?
L.
L.
So you know what? We're going to do that multiplication first.
Sine L.
12.
Right? Let me multiply this. How am I going to write that?
12 sine L,
12,
sir.
so
Yes, 12 times sine L. And that's going to be equal to what?
10 over sine 88.
Nah, 10 sine 88.
Okay.
Because we're multiplying, eh? We're multiplying. That's why we say cross multiplication. Because watch, we're multiplying these two things by each other. So 12 by sine L, so 12 sine L. Right? Over here, 10 by sine 88 or 10 sine 88. Nice.
Oh, all right.
So I wait to stay unmuted, right? What's the name of my chance person I'm talking to?
Then L.
Oh, Danelle. Hey, Danelle, where's your plan?
Yeah, they.
All right, yeah. Here we're gonna do, right? We want to
Yes,
find
sir.
sine L first. Sine L. If we want to find for sine L, that should be the only thing on the left-hand side. But right now, it's currently being multiplied by what?
By 12, sir?
Yeah. So we had to get rid of that 12. What's the opposite of multiplying by 12?
Division.
Right? So we're going to divide both sides by 12. And when we do that, that 12 and that 12 going to cancel off. And that will leave us with sine now. So I confused you so far at all. Like, I don't know what we're going to.
No, sir, I get.
So here it is, right? We want to find the angle. So what is the opposite function of sine called? Sine what?
Sine theta.
Sine inverse.
Sine inverse. Okay.
To find for L, you would need to find sine inverse of everything that's on the other side. So you need to find sine inverse of all of this. You have a sharp or a Casio?
At the moment, I sharp, but I'm trying to get a Casio right now.
Let's look if you have a sharp. I'll show you what to do, right? But guys, those who have a Casio or a Sunway or a Quast, whoever, plug this into your calculator and let me know what you get. If you have a sharp, this is what way to do. So I want you to put 10 sine 88, right? Then press divided 12. Right? So then now put that into your calculator and let me know if you get 0.832825696892.
Okay.
Yeah.
Actually, then I'll make sure you get a nut.
Wait, I got 56.
Yeah. I just taken it in parts, steps, right? For those who are sharp.
Yeah, I get it.
Right? So Faith, when you find sine inverse of that, you'll get a 56. But we can it in parts. Right. So then now, I want you to press on now. That should clear the screen. Right? So you have a blank screen.
Yes, sir. Yeah, my blank screen right now.
So what your calculator does, right? Your calculator automatically stores your previous answer. And to get back the answer, you have to press alpha equal. So wait,
Okay.
your screen is clear, right? Right now, right? It's clear.
Yeah. Yeah, it's clear right now.
I want you to press second function sine. And you should see sine minus 1 pop up.
Okay.
Let me know if you see that.
Yeah, sir.
Next up, I want you to press alpha equal.
Okay.
Right? Anything come up?
I think I gained some problems, yes, sir.
All
I
right.
just think it's a calculator, sir. But I understand so far.
All right, let me make sure I know how to do it. So wait, let me return my sharp. All right, so you have to press equal again. So let me run it back one more time, right? So clear your screen. And just to clarify, do you have the EL506TS model or not?
DEL 50, yeah.
All right, so what you want to do, right? You have the answer stored already. I hope. Just to make sure you have the answer stored, I want you to press alpha equal, then press equal again. Actually, no, that.
Okay, alpha
Then
equal. And then press the second. Yeah?
wait, give me a second. Let me just make sure. Okay. Give me a second.
The sharp is a real failure, I think.
I'm telling you, it's crazy. It's crazy. All right, so you got the 0.83, right?
Yeah.
All right, cool. Next thing I want you to do, I want you to press second function, sine.
Okay.
Right?
Yeah.
Then I want you to press open bracket.
Open bracket.
Then I want you to press alpha equal. Then close bracket, then press equal.
Again, 0.
That's weird. Again, 56.39.
Okay, let me try it again. I'll tell if I get.
Back one more time. So I want you to put 10, put 10
Okay.
sine 88, 10 sine 8
10 sine 88
divided by 12,
divided by 12.
and it should get 0.832825689. Yeah?
I get that.
Press on/C. So clear the screen.
Yeah, on.
All right. Then I want you to press second function, sine.
Second function,
Sine.
sine.
Right? And you can just press alpha equal.
Okay. Alpha equal.
Press equal.
I get 56.39.
Nice. That's it. That's what you're supposed to get.
All right, thanks. Sir.
No problem. If you have a Casio, this is what you're going to do, right? You're going to plug it in exactly how you see it. Exactly how you see it. So 10 sine process. Did you get through?
Yes, sir.
Process. You're never going back to a sharper. Never. Never, ever, ever.
Yeah, no, sir, no.
I think I could show you mine because I thought of all this kind of acrobatic thing with this sharp.
Yeah,
It's too
boy.
much.
Like I tell you earlier, like when you Casio, you plug in it exactly how you see. There's no tricks or anything. Like you just do it on paper and then put it in the calculator. Right? Right. The units will be kilometers. Yeah. So guys, are we okay with this question? Wait, why I say kilometers? My bad. That'll be degrees, right? Yeah, let me know if you got 56.39 degrees. Yes or no, guys?
Yes, sir.
Did anybody not get 56.39 degrees? If not, tell me no. Darius, the Marco got 56.39. Ask him.
You got 56.39? You say it.
I hear him. Nice. Proper thing. Right. So are they ready to move on from this question? I'm gonna.
Yes, sir.
All right. So the answer, this is the calculation here. And the extremely looking, it's right here. All right. So guys, I have a question, right? They just don't ask me to find for an angle. Now they're asking me to find for a length or a distance. What do you think we can use now?
Cosine rule.
Yeah. We're gonna use cosine rule. We're calling it like that. So what we to find for NR. Any question? NR. Right? NR. So guys, can we see that this is NR? Yeah or no? Guys, let me know. Are you seeing the NR?
Yes, sir.
Yes, sir.
Okay. If I'm looking at that triangle, right? If I am looking at this triangle, are any of you all seen an included angle? And if so, what angle?
25 degrees.
What about the rest of you guys? Are you all seeing 25 degrees?
Yeah.
Yes, sir.
And it's in between two known lengths. What are the lengths it's in between?
18 and 12.
How about the rest of you guys? Are you seeing that 18 and 12 or not?
Yeah, I see this, sir.
The now.
Yeah.
I wonder if you're seeing that the now. So like, this is the
Yes,
angle.
sir. Yes, I see it.
All right, Wood, Adika, Celine,
Yes, sir, I seen it.
Yes, sir.
Yes, sir.
Aaron. Okay. All right. So great. I'm going to take this triangle and just look at it separately. Hey, why are you yawning, boy? I don't know why you're yawning so much. That's so weird. All right. So this is L, this is N, this is R, this is the 18 kilometers here. This is the 12 kilometers here. This is the 25 degrees over here, right? So guys, help me label the sides. Better? Now, I want you to help me label the sides, right? So then now, if this is angle L, what side do you think I'm going to call this?
Someone else.
This angle N, I'm going to call this.
Someone M.
Yeah. And this angle R, what am I going to call this?
Someone R.
Right. So when you're using the cosine rule, you're finding for the side opposite the included angle. So what's the side I'm finding for here then now? L, R, or N?
Answer.
N. All right. When I say find for something, I mean like we don't have it at all. We don't have it, so we gotta find for it. Do we know what N is? Come on now. Do we know what N is?
No, sir.
Yeah, sure. I see an 18 in there.
Oh, yeah, I see it. I'm sorry.
That's okay. Do we know what R is?
Yes, sir.
What's R?
R is 12.
Right. What's the only one we don't know?
L.
Yeah, we don't know what L is at all. So let me show you how the formula would look like. Right? So the formula, I'm gonna write it out in words, and then I want you to tell me what I'll write. I think I can copy and paste it to save some time. Give me a second.
So we're using the same formula was A squared is equal to B squared plus C squared and so on.
Yeah, but I want you to write it. I want you to tailor that formula to the question. You just write the formula. I want you to tailor it to the question. Because each questions are going to have different parameters. I say in some fancy words here, but what I mean is that different questions are going to have different letters. So not all the questions are going to have the same letters. So watch this. This is the formula in English, right? So it's the opposite side. So tell me.
N over R divided by
No.
a
This
half.
is the cosine rule. Wait, this is the cosine rule. This is the cosine rule. We have an included angle, 25 degrees, right? So is the cosine rule, right? So then now we start off by saying the opposite side squared. So tell me then now, what is the side opposite the included angle? Tell me then.
Answer.
Say that again?
L.
Yeah, L. So we say L squared. And that's equal
Okay.
one of the adjacent sides squared. What is one of the adjacent sides?
R.
Right? So R is one of them. So we can say R squared, right? Plus,
Plus N squared.
right? Just keep going. Minus.
Minus 2 open bracket.
Yeah, I could put the open bracket, but when you're writing the formula, I don't need to.
Okay. R
Mm-hmm.
R by N
Right? Mm-hmm. Solve our part to tell me.
cos and 25.
Right.
25 degrees.
I want to put capital L, right?
Okay.
Because that's the angle. But you're right, 25 degrees. Right. So guys, if I want to find for L and I want to jump straight to the answer, L would just be the square root of R squared, so 12 squared, plus 18 squared minus 2 by 12 by 18 cosine 25. Now, did anything I did there confuse you? Maybe you're confused about the square root sign. Tell me.
Nah, I see you use the square root sign a couple of times. So I understand because how it is we have R squared and so forth and so forth. So see you use it a couple of times. I custom with that. I
Okay.
understand so far.
So you understand that the opposite of squaring something is the square root it.
Yeah.
And when a square root, a square will cancel off to leave one L.
Yes.
And if I do something on one side, I'll do it on the
Yeah, they do it on the other side too.
Right. Yeah. So, people with a class, you guys shouldn't have a problem getting the answer, right? People with the sharp, let's do it together. So, Danelle, I want you to press 12 squared, right,
Okay.
plus 18 squared, right, minus 2, open bracket, 12, close bracket, open bracket, 18, close bracket, cos 25, close bracket. So, then I'll plug this into your calculator and let me know what you get.
I get 76.47, sir.
Great, great, great. That's good. So, way to clear now, press on/C, right? Then I want you to press the square root button, press the square root button, right?
Yes, sir. I get 8.74.
Okay, you remember how to get answer. Nice, nice,
Mm-hmm.
good. Yes. Big up yourself. People with a sharp, did you all get 8.75 when you round it
Yes,
up?
sir. Yeah.
Okay, good.
So we could just run through the rules again
Sure, no
for
problem.
like sine, cosine, and tan,
Wait,
please.
think you mean to say sine and cosine rule. Anytime you're dealing with a triangle that don't have 90 degrees in it, it's sine and cosine, not the trig ratios. I feel like you're mixing up the trig ratios and sine and cosine. So let me
I thought it was the same thing.
no. The trig ratios is sine theta is equal to O over H, right? Cos theta is equal to A over H. Tan theta is equal to O over E. These are the trig ratios. I can only use these if you have a 90-degree angle triangle. Are you seeing right angles anywhere here?
No.
No, so you can't use that, right? If you know triangles that are not 90 degrees, you will use the sine rule, right? Which generally looks like this. A over sine A is equal to B over sine B is equal to C over sine C, right? And the cosine rule. Cosine rule. The cosine rule will generally look like this. A squared is equal to B squared plus C squared minus 2BC cosine, right? And fate. You would use the sine rule when you don't have an included angle. Let's put it like that. You would use the cosine rule anytime you see an included angle. Do you remember what time this?
Included angle.
You remember what an included angle is?
Yeah. It
So,
must have both sides.
right.
Close.
So in part 2, they wanted me to figure out the distance NR, right? So can we see that this is NR? Some of it as NR,
Yes.
right? So we're gonna consider this triangle then. If their length is NR, we'll be looking at this triangle. So for that triangle, are you seeing any included angles?
Yeah, the 25 degrees.
Right. So you do have an included angle, so you're going to use the cosine rule. So the side opposite the included angle is L, so I'll say L squared is equal to the one of the sides right next to the angle squared plus the other side squared minus 2 times the adjacent sides, right, multiplied by cos of the included angle. So fit. If you have an included angle, you use cosine. If you don't have an included angle, use sine rule. And fit,
Okay.
you only do these things if you have a triangle that is not what? Not what?
90 degrees.
Exactly. If it don't have a 90 degrees in it, they would use these. That clear up the confusion?
Yes.
Okay. I'll leave this in the notes, I suppose. Right? Right. I have a question over here. Right, so now, let's figure out the bearing question right now. So in part three, what are they asking us for?
To determine the bearing of tone R from tone L.
From where?
From R from tone L?
From where? Wait, I just asking to emphasize it. From where?
Tone R from tone L.
So from town now, right? From
Yeah.
town. If it's in from town now, where am I going to put on my note line?
Toner.
Yeah. Guys, if you see the word from, put on your note line there, right? So I'm gonna put it by L, and I want to go to where? Tell me that now. I want to go from L to
R.
right. So I have an outline already by L, and I want to go to
R.
right. So can we both agree that this is a line connecting L to R? Yes or no?
Yes. Yes, sir.
Right? So the bearing will be from the north line in our direction. Clockwise or
Clockwise. Clockwise.
clockwise? So that's the bearing, right?
Yes, sir.
I know that this is 50, and I know that this is 25. What am I missing?
The middle is sir.
The middle, right? And waiting to make we find 4 in part 1. They make we find for the angle. Right?
Oh, yeah.
Yeah. So you see everything coming like full circle now?
Yes, sir.
Because they made us find 56.39 degrees. So like this bearing will just be the sum of all of that. So if you add up all of that, all you get. So 56.39 plus 50 plus 25.
So I get 1 to the 1.39.
What about the rest of you guys? Look at it now as what? That sounds correct, by the way. 1 to the 1
Yes,
point.
sir.
Right? Okay, guys, how we feeling with this question so far? Like, was it hard or was it easy? I don't know.
It was a good question, sir.
It was easy.
All right. What about the rest of you guys? Like, let me know. Like, you have anything here that you feel like you just can't do at all, and you feel like to give up on life, and if you're feeling like you're feeling like this. If so, right, tell me now. I will go over whatever confusing you. Right, I promise. I will not judge you. Just tell me now. Right? Anybody confused?
No, sir.
No.
No, sir.
Okay. So let's move on to another question. Were there any other trigonometry questions this year? Sometimes they go split it up for some reason. No, there was not. Right? It's okay. Give me next year, guys. Give me another year. Give me another year.
January 2022.
This is January 2022.
January 2023.
Sure. That's quite true. It'll be crazy if I don't have that. So I will. Give me a second. I'm just getting past the pass. A parrot. I'm a coral cute. Just chilling there in the back. Like,
Yeah, he quiet.
like a chill guy. A chill guy. All right, so let me jump straight into it, right? Let's not delete that. All right, so who wants to help me with this question? Do I have any takers? Do I have any takers?
Let's
Pete, you wanna go?
The diagram below shows 4 points, P, Q, and R, and S, on level ground, where pillars will be placed to mark the outline of a foundation. There is a vertical post, RT, CNT, at R from Q. The angle of elevation of the top of the post T is 21 degrees. Find the height of the post.
So this question sounded a little scary.
Yeah.
It'll be fine. It'll be
Yes.
so like I'm gonna explain what happened in here, right? So they say on the diagram below shows 4 points on level ground, right? So all of this is level ground, right? This is like imagine you're Superman and you can look down, so you go see. This is ground. All this is like flat ground, right? And they're saying that there's a vertical post RT at R. So Faith, where do you think we're gonna put the post? Where? Tell me, Faith, where do you think we're gonna put the post? At where?
At R,
Right. And what do you think we're gonna call the top of the pole? I mean, the top of the post.
hopefully.
Say that again?
T.
Yeah.
Oh, okay. T.
Right, so that's why they're saying RT, right? At R. Right? So from Q, so like what? From Q, imagine if you are at Q, right? They're saying the angle of elevation of the top of the post T is 21. Remind me, guys, when I say angle of elevation, am I looking up or am I looking down? Angle of elevation. I'm looking up, right? So they're saying from Q, you have an angular elevation. So imagine that you was by Q and you was looking up at the top of the post. You understand what's going on so far?
Yes.
So guys, if you are confused, you mightn't tell me. So I'm gonna go it over again, right? So Faith, actually, I'm gonna call Darius. Darius, you there?
Yes, sir.
So Darius, they're saying you put on a vertical post, right?
Right.
On RT at R. That means you put it on the post where? At where?
At R.
Right. And if this here is RT, we think we're gonna call it top of the post.
Not.
Nah. RT. R to T.
T.
T, right? So they would call it T. So this is the vertical post they're talking about, RT. Now they are saying from Q, so you're at Q, right? Let me just draw you. You're at Q. Just try with your McCall. Buddy. Right? Say at Q. According to what they're saying here, they're saying angle of elevation. So Darius, what does it mean, angle of elevation? It means that you're looking where down or up.
Up.
Right. So guys, if you are confused, imagine you're standing up at Q, right? Remember, all of this is level ground. You're on the ground. So Danelle, imagine you're on the ground, right? Yeah?
Yes, sir.
Imagine you're on the ground now. and you're over here at Q, and you look up to T, wouldn't there an angle be forming between your line of sight and when you look up? Like,
Yes, sir.
I mean, so like normally you'd be looking directly ahead, right? But if you look
Yeah.
at something, the angle will be in the middle.
Yeah.
So that's what they are talking about here. They're saying from Q, so from Q, the angle of elevation, so you looking up, you're looking at the top of the post, is 21 degrees, right? So the marks are questioned now.
Yes, sir.
And it makes sense for the 21 to be over here.
Yeah.
Because
No.
what's going on, right? And angle of elevation is the angle formed by looking up at something.
Yeah.
So if you are looking to the top of the pole and to the top of the post T, then the
Mm-hmm.
angle is 21 degrees. That's like how far you ought to look up in terms of degrees to see the top of the post T. Tell me if you understand that.
Yeah, I understand, sir.
You're sure?
Yeah.
Taking off my glasses. You're sure?
Yes, sir.
All right. What about the rest of you guys?
Yes,
This is
sir.
a little bit confusing. I know, like, tell me if you're confused now. It's fine. I'll go it over. Tell me, guys. Celine, you there? It's like Celine, not Cody, boy. All right, guys. So, Faith, do you understand what they're talking about? Yes or no?
Yes.
Yeah, all I seem to one in the background. Yeah. So, Faith, do you understand that you're at Q and you're looking up at something, so angle in the middle. That's all. That's all that happening over there. Right? And let me ask you a question.
Yeah, I understand that.
So, Faith, all of this is on the ground, yeah? And all of that's on the ground, right?
Yeah.
And this is,
Yeah.
okay, if it's on the ground, you would say horizontal. So all of this is horizontal. And a pole, obviously, a post, right, would be vertical. Yeah? Watch. So like, imagine my house
Yeah.
is the ground, and this is the post. What is the angle formed in the middle? What angle is that? Between vertical and horizontal. Come on. Like this one.
Um,
90.
that is 21 degrees.
No, 90. 90. Faith, if you
Oh, okay.
watch,
Okay.
if this is the ground, if this is the ground, right? And you put something into the ground, what angle are you looking like in the middle? Come on, Faith.
90 degrees.
Yeah. All right, so that 21 is actually the angle that will be formed.
90 degrees.
Yes, so that angle, that 21 degrees, is actually the angle that will be formed by you looking up, right? But I want to explain something. And we just said that this is ground, that flat, right? Yeah, that flat. And we just said that Faith, said that all of that was the ground.
Yeah.
And this is vertical. What's the angle formed between the ground and a post? Remind me. If you have a ground and you stick something into the ground, what's the angle in the middle? Of it?
90 degrees.
So it might be hard to see, right? But you are dealing with a right angle triangle. And why am I saying that? Again, I'm saying that because this is a vertical post, right? And this is the ground. So it's kind of hard to see, but if you were to look at this in real life, this would be like flat ground. You'd be standing on this and you'd be looking at the post. And the angle between the post and the ground would be 90. Tell me if you understand what I'm saying.
Yeah, understanding.
Now, this kind of hard for a lot of students to see. And I don't get them wrong. Like, it's kind of abstract, kind of hard to see because it's a diagram. But all of this is flat ground. All of this is flat ground. So, like, I have a question, right? Faith, if I wanted to put a pole over here, what would be the angle between the pole and the flat ground?
You just make a line here. So I want to say 90 degrees.
Yes, because if you look at this in real life, right, and you could be standing up on this ground, and you would be looking at the
Yeah.
pole, right? That would be 90. Like you planted the pole on the ground. So the angle between the pole and the ground is 90. I don't the diagram confuse you. So they want us to find the height of the post.
No, this was just my first time having to draw out something.
But you understand it?
Yeah.
All right, so this is what we're dealing with. This is Q. So we're actually dealing with a right angle triangle. For those of you that didn't see it, yes, we are dealing with a right angle triangle. So this is Q, this is T,
Yeah.
R, and the angle here, what's in angle? This length over here is 153 meters. And the angular elevation was 21. Why? Because that's the angle that would be formed if it was at Q and you looked up at T. Right? And they want us to find the height of the post. So what are we trying to find for here, guys? QT, TR, QR. What are we trying to find for? Height of the post. Somebody tell me. Height of the post.
TR.
Yeah, we want to find for TR. So let's just label our right angle triangle. So guys, will we be using sine rule and cosine rule for this question?
No, sir.
Yes.
Somebody say yeah. Remember, let me go back to this quickly. If it's a right angle triangle, I will use trig
No,
ratios.
it's trig ratios.
Right.
That's what I mean, but like with SOA. So sine theta. That's what I'm trying to say. Sorry.
That's okay. It's trig ratios. Trig ratios. So like over here, sine is being represented as a ratio of two lengths. That's what all of the angles are. They are just a ratio of the sides. It don't have anything to do with these formulas, right? So let's label our triangle accordingly. So this side is opposite the right angle. So what would I call this side, guys? What would I call that side?
Hypotenuse.
Right? What would I call this side? What would I call this side?
Adjacent.
Yes, yes. Because this is the angle, guys. If that's the angle, and you all can see that this length is right next to the angle, so it's adjacent to the angle. Yes or no?
Yes.
Yeah, we can see that. And this side is what to the angle?
Opposite.
Yes, opposite. So we want to find the height, right? Height of the post. So that'll be TR. Immediately, I'm going to underline that. And what do I have? What length do I have? Tell me, guys.
153.
So, okay, which trig ratio has 1A in it? 1A in it.
Tan.
Tan, right? So we're going to say tan theta is equal to O over A. Right? So my angle is 21. So tan 21 degrees, and that would be equal to what over what? What is O?
It's have nothing on O.
Say that again?
So we're missing O.
Right. So we're going to call that RT. Right? And what's E? What is E?
153.
right? 153. All right, so guys, question. I can write tan 21 as tan 21 over what?
One.
And since I have a fraction on either side, what I could do?
Cross multiply.
Cross multiply.
All you understand is the same thing we're repeating over and over, right? It's like, it's the same steps, it's the same procedure, right? So process, what we're going to end up with? So process, we want the unknown to be on the left-hand side. So you should probably do the multiplication with the unknown first. So tell me,
RT1.
wait, yeah, I want process to answer. So process, tell me, how am I going to multiply this?
RT
Right? 1 by RT is RT. What next?
equals 153 tan 21.
Let's go. Let's go. Big up you. Right? Process. You go pass. You go pass. Big up yourself, right? So process. Plug that into the calculator. And let me know what you get. Let me know what you're getting.
$58.73.
Right? And I was somebody to verify that. 58.73 meters, right? You're getting that?
Yes, sir.
All right. Say no more. Say no more. Right? Okay. So the hardest part of this question was to like interpret it. That's the hardest part. But once it did, it's easy. Is there anybody that'd like me to go over this question again? Or like, does everybody here feel like they understand what it was asking? Like, let me know.
Yes, sir.
I understand.
Give me some energy now, boy. Give me some vibes or something like, let me know. Let me know what's up. Let me know if you understand this.
So we understand.
All right. I gotta get tired. Okay, I'll be honest, I'm feeling it too, but energy. All right. Okay, and then we have a 4-mark question. We have a 4-mark question, guys. A 4-mark question. Who wants to do the 4-mark question with me? The 4-mark question. 4 marks. Do I have any takers? I promise it's not that hard. I promise. I promise. It's like the same things you was doing over and over and over.
No, you wanna.
Yeah, Darius. Good old reliable Darius.
Given that the length QS is 153 meters, calculate the diameter
You
of
think,
the
you said you think Guyanese for a second there. You said 153. Guyanese people is like sometimes they would it's a chicken curry chicken, you know that?
right.
So you
Oh,
say
okay.
one say
My
one
bad,
three
my
instead of
bad.
135.
135 meters. Calculate the perimeter of the foundation PQRS.
All right, so it's a 4-mark question, guys. And we're dealing with length. So maybe we might have to use what rule? Tell me, Darius.
Cosine.
Maybe. We don't know. We'll see, right? So QS is 135. Right? So QS is 135. Darius, I think you're smiling. I think you're seeing it, boy. I think you're seeing it. Watch that. Watch that. You're seeing the included angle already, Ant? Where's the included angle? Wait, let somebody else. Wait. Guys. Are you seeing the included angle anywhere there?
Yeah. Yeah.
What is the included angle? What's
By
it?
Q,
Q. And where's the angle? What's the angle?
29.
Let me go. Right? So you see, we call that. You see a 4-mark question, right? And we see length. Automatically, a perimeter, right? Perimeter is the distance around, so length. I don't know. I might have to use cosine rule. I don't know. I might have to use the cosine rule. Yeah. Right. So guys, let we calculate this thing fast. So we're dealing with this triangle here. That's the area. So we go, right? So this is Q, this is P, this is S, this is 83 meters. This is 135 meters. Right? So I want to do one more question, right? A bearing heavy question. And then I'm going to give you all a break, right? Then we are going to move on to algebra for that song.
Yes, sir.
And I want to volunteer for the next question one time as well. Now, I feel like I'm looking at it now.
Yes, sir.
I can wait, but I can sense the excitement in your voice. You're excited. Be outside. All right. Yeah, don't worry, don't worry. We can do the next question together, all right?
Okay.
Right? Yeah. So Daria, so we label these sides, right? We label these sides. If this is angle Q, what would this be?
Come on, Q.
Right? It is angle P. What do we call this side?
Come on, P.
It is angle S. What I call this side?
Yes.
Right. Common S. So and you can see that we find for Q.
Right.
And isn't that opposite the included angle, as always?
So,
Right. So let me write the formula for this. It's going to be 1Q squared is equal to
Q squared is equals to 83 squared plus 135
right.
squared.
The formula puts. Let's give a mark for it in the formula. Let's give a mark the formula. So Q is equal to S squared plus
P squared
PQ minus yeah.
Minus 2PQ.
No, 2PS.
Oh, wait, my bad.
Darius. Check this out. Check it out, Darius. When you do the cosine rule, right?
Yes, sir. I know. It's just the two lengths there, but I mix up the letters.
Oh shucks.
2PQ, 2PS plus 2Q.
Right, cos Q. Right. Cool. Hey guys, so again, they wanted us to find the perimeter, right? The perimeter is the distance all around. So as you can see, we have 83 here. We have 153 here. We have 110 over here. But until you can see we're missing this part over here. Are you seeing that, right?
Yes, sir.
So obviously that's what we need to find for. And we're going to use the cosine rule to figure that out. So let me run this thing real fast. So if I want to find for Q, tell me now, we'll have to find a what? The what? Start with S. Remind me now.
Besides, sir.
The what?
I forget it.
All right. What is the opposite of square and something?
Square root.
The square root.
Exactly. So you have to square root both sides. So Q will be equal to the square root of everything overhead. So like S here is 83. So I'll say 83 squared. Right? P is 135. So I'll say 135 squared. Right? Minus 2, open bracket. P is 135. S is 83. Right? Cosine Q, which is 29 degrees. Right? So guys, plug that into your calculator and let me know what you're getting for Q.
74.25.
All right. Could you all verify that? Hey boy, Perseus, you really getting a somebody can see you, boy.
So I get 75.82.
Let me see. Let me plug it in and see what I get. Let's see what I get. Again, 74.25. Precise. That was the answer you get.
Yes, sir.
Darius, I'll check something.
I get a two, sir.
Yeah, it's the correct one. All right, check back. What you do there? Right? All right, so 74.25.
I got that, sir.
Right? And that's going to be in meters that we're finding for our length, right? All right, guys, so we know that Q is 74.25. This is 74.25 meters. Darius, you figure out where was your error? So you got a slightly different answer. Tell me, Darius.
Last year, I plug in the thing the same way and I get the same thing.
That's weird. Like exactly how I plug in it in. Is your calculator in degrees or gradients?
Degrees.
You're using rounded off values, or like you're plugging it in one time, like straight out.
I plug in it in one time.
All right, let me run it back one more time, right? So clear the screen, Darius. Press square root, right? 83 squared plus 135 squared, right? Minus 2, open brackets, 135, close bracket, open bracket, 83, close bracket, cos 29, close bracket, equal.
Alright, so I don't know how I get 82, right? But I don't know what's going on.
Oh, you had 82 instead of 83. Oh, hey boy. Yeah, guys. So I want to ask you something. Did we finish? Are we done with the question or we have more work to do? Tell me. Tell me, guys. They ask us for the perimeter, right? So I think we finish or we still have more work to do?
We have more work to do.
Yeah. But is it plenty work or like easy work?
So they just add up the sides.
Yeah, that's all. That's all. Or I think trigonometry like hard or like it manageable?
Manageable.
For sure, right? For sure.
Manageable.
The perimeter is going to be equal to just 153 plus 110 plus the 74.25 plus the 83. And if you are confused, right, perimeter refers to the distance around a shape. So they said PQRS. So PQRS and back to P. So that entire perimeter, the outer perimeter, the distance around, I'll just have to add up everything. So when you all did this, what did you get? Tell me, what did you all get? What did you guys get?
420.25.
420.25
Yes, sir.
meters, right? How about the rest of you guys? Did you all get that?
Yes, sir, I got that.
Yes, sir.
Say no more. Say no more. Right. So that was an easy for Max. So like this was the only hard part was really trying to understand what I mean in the first part, but other than that, it was easy. Right. So that brings me to our question, right? Guys, if I were to take a pole and if I was to take a pole and plant it at P, right? Right, so look what I'm doing. What would be the angle between that pole and any point over here? Like if I were to, let me just say, create this triangle.
90.
Yeah, guys, do you all understand that this would be 90 degrees over here or not?
It would.
It would. Then now, it's looking a little confusing, right?
Yes, sir.
All right, but then now,
Yes, sir.
put a pole in the ground and vertically,
Yeah.
and everything here is on level ground, so like it's flat.
Yes, sir.
If I put a pole here, and this is ground, everything here is ground, what will be the angle between the post and the ground?
It will be 90 degrees, sir.
Yeah. So the angle between this and the ground is 90. I know it's looking a little hard to see, right? But yeah, it will be 90. So
Yes, sir.
anytime you're talking about angle between vertical post and ground, anytime you see these sets of questions, 90 degrees, right? 90 degrees. Yeah. Let me look for a question.
So if it is, you didn't show me that and do that in class today, I'd be so confused when I go in the exam because I wouldn't have see it myself. But when I explain it, it make more sense because, now, I wouldn't look at everything as us, as the ground and stuff like that.
No, I understand. Like, yeah, it's kind of confusing for sure. Okay, yeah. Nice. Next question. Yes, man. Right, so we have a question here, right? And we have a question here. Lovely. It's a lovely question. Testing like every single thing you learned so far. How nice. So, Danielle, enter the question. Did you do the question on my next?
Yes, sir.
Great. So, give this question a read for me.
PMQROS is, that's now you can bring it all over the place, right? Is a cross section of a play area in the park. PQRS is a rectangle and PMQ is a semicircle. O is the midpoint of RS. OP is equal to OQ equal to 15 meters and angle POQ is equal to 40 degrees.
Right.
Use pi is equal to 22/7.
Right. And the first part, they want us to determine the value of angle OPQ. OPQ. So, this is O. So, OP theta, right? So, O to P to Q. Tell me, they are talking about angle. Tell me now, the angle, angle OP or Q. What do you think they're talking about?
P, sir?
Yeah, talking about P. Mhm. Okay, cool. So we need to figure this out, yeah?
Yes, sir.
Now, anytime you see these lines, what kind of triangle are you dealing with?
Isosceles.
Isosceles.
Right. Remember, we do isosceles in circle theorem yesterday.
Yes, sir. So the base will be the same.
Exactly. And the base is the remaining side, right? So this will be the base. So over here,
Yes, sir.
this will be the base here.
Yes, sir.
So like, in other words, this angle and this angle will be the same, yeah?
Yes, sir.
All right. And we know that this is 40 degrees. So how do you think I'm going to find for those two angles?
By minusing 40 by 180.
Right.
40 by 180 is 140, and we could divide it by 2, or yeah, divide it by 2, and we get 70. So it'll be 70 on each side.
Um, performance, right? 70 degrees, right? Right, length of OR now. OR. OR. So the way to find this length over here, check it out. R. Seeing that?
Yes, sir.
Now let me answer that question. If the way to find for OR, the first thing I would ask is, what kind of triangle is this?
I kind of looking like a 90-degree.
Yeah. Now remember, they said PQRS is a what?
Oh yeah, it's a right triangle. Okay.
It's a rectangle, right?
Rectangle.
And
Rectangle.
the angles for a rectangle is always 90 degrees. So
Yeah.
we know that this is 90 degrees for sure. For sure. Right? No doubt about it. That's definitely 90. Right? Definitely 90. So like that is 90, right? And let me ask you this. What would this side be? Tell me, what would this side be?
The hypotenuse.
Hmm. Yeah, well, if it's the hypotenuse, you're not wrong. It is the hypotenuse, but what's the length? We know the length.
15.
Okay, yeah, because 15 on the other side.
Right. The isosceles.
Yeah.
So how much sides do we have?
We have two sides.
So what we should use?
We will have to use
Anytime you have two sides, you can use what?
the cosine of.
And let me say something, right? You only use sine and cosine rule if it's a triangle that is not 90 degrees. If it's not a right angle triangle.
Oh, so we gotta use the next one.
So wait, a way to forget, like, okay, sine and cosine rule, forget about that. If you see 90 degrees, forget about that. You're gonna use Pythagoras theorem or trig ratios.
Okay.
Right? Now you use Pythagoras theorem anytime you have two sides. So do we have two sides?
Yes, sir.
Right, so we're going to use Pythagoras theorem. So this is O, this is R, and this is Q. So Pythagoras theorem says that the hypotenuse squared is equal to the sum of the other sides squared. So what is the hypotenuse here?
15.
Right, so that'll be OQ, and
Yeah.
I would say OQ squared is equal to what squared plus what squared?
It will be equal to 14.1.
We write in the full formula here. So OQ squared, right? So QR squared plus
Plus Q
all
O
right,
Q
so
O squared.
now
Oh no.
remember Pythagoras theorem is okay. Pythagoras theorem says that the hypotenuse squared would be equal to the other side squared plus the other side squared. So now the hypotenuse here is what? What's the hypotenuse here?
15.
Right, so that's OQ, yeah? OQ. OQ,
Yes, sir.
what?
Oh,
And the other sides is QR, and what's the other side?
second raise it a little bit, please. Right. OR.
Yeah. Right, so what is OQ?
OQ is 15.
Right, so 15 squared, and that will be equal to QR. What is QR?
QR is 14.1.
right? So 14.1 squared. Uh-huh. And we don't know what OR is, so I'll leave that blank. So we simplify now. What is 15 squared?
15 squared is 225.
Right? And 14.1 squared is?
14.1. 198.81.
It's so cool that my watch could do this. Like this is so cool. Like, watch this. That's crazy, right? That's crazy.
Yeah, so
Yeah, well, yeah, 198.81.
And there's a Casio too.
It's a Casio, of course. Of course. Right? I should just be the brand ambassador for Casio at this point. I know advertising watches too, but so yeah, don't know. What's the unknown here? What is the unknown?
OR squared.
So what shouldn't be here then? So if you're trying to find for something, it should be the only thing on that side. So the only thing there should be OR squared. So what should I move across?
The 225, sir.
Nah. So the only thing that should be on this side is OR squared.
Okay.
So what should I move across then? If the only thing that should be here is OR squared, what shouldn't be there?
198.81.
Right. If I move that across, what's going to happen to the sign?
It will change
It will change to what?
a negative.
Yeah, a negative. Right? And that will be equal to OR squared. What is 220
Okay.
minus 198.1?
225 minus 198 points.
Boy, this that's
It will be
26.19. No, if you're getting 26.19.
just I'm gonna do it twice. I feel like I do something wrong. One, mhm, mhm.
Yeah, so you get 26.
Yes, sir. 26.19.
Imagine just going in the maths exam with a Casio watch with a calculator. That'd be crazy. The marks you weigh calculator, I say, come on, right? Okay, one thing you can't do, you can't find square root, unfortunately, right? So, then now, what's the opposite of square and something?
Square root, sir.
Right, so you're gonna find the square root on both sides. And that will leave you with OR.
Okay.
So OR would just be equal to the square root of 26.19. And what would that give you?
I'll get 5.1176.
It's 5.12.
Yeah, 5.12.
Could you all agree? Let me know if you guys okay with this. Yeah or nah?
Yeah, sir.
All right. And I feel like I need to like go over this again. Like I'm gonna explain what I go over. Guys, the sine and cosine rule is only for what kind of triangles?
Non-90-degree
Non-right angle
triangles, sir.
triangles.
Exactly. If it's a right angle triangle, what are the two things you're gonna use?
Pythagoras theorem and trig ratios.
Exactly. No sine and cosine rule, right?
Trig ratios.
I can't stress that enough. If you have a right angle triangle, trig ratios and Pythagoras theorem. All right. So this question was a little heavy. All right, it was a little heavy. Right. So guys, Now they want us to calculate the area of the shaded portion of the diagram. Okay. So guys, remember I showed you all a cool formula for how to find the area of a triangle. I'm going to show you that. Yeah or no? Did I ever show you all a formula for area of a triangle if you had the included angle?
So that
Yeah,
was
so I think you did.
Yeah.
It was half adjacent by adjacent sine the included angle. And
Yeah, that was it. So watch this, right? In this question, do we have a triangle with an included angle?
Yes, sir.
Yeah, this is 15 and this is 15. So we could do that, get the answer one time, right? So the area of a triangle, right? So area of triangle, it's going to be equal to a half. Let's try the formula first. So if there's capital O, this will be common O. If this is angle P, this will be common P. If this is angle Q, this will be common Q. So my formula is going to be a half, right? What are my adjacent sides? What are my sides right next to the angle?
Q1P.
Yeah. So I'll say a half QP by, right? So I'll say a half QP sine what? Was it included angle, guys?
40 degrees.
Right, sine O. So that's going to be a half, right? Q is 15, right? P is 15, right? And my angle is 40. Plug that into the calculator and let me know what you're going to get. Are you getting 72.31?
Yes, sir.
Pretty good. And that wasn't the only way you could have do it, eh? But that's like the easiest. One with like less working. Like with the least working. And now we meter squared. Now, realistically, let me show you another way you could have do it, right? And do we know what OR is? Yeah? And do you know what OR is? Yes or no? And OR was 5.12.
Yes, sir.
So check this, huh? If OR is 5.12, and the whole thing will be 10.24. Yes or no?
Yes, sir.
So this will be 10.24. And wouldn't the height be 14.1?
Yes, sir.
So watch this, right? So 2 times, I using the exact values, right? To show you a proof of concept. So 2 by square root is 26.19, right? That would give me the base. Why? Well, remember, 5.12 was half. So the whole thing will be just 2 times that, right? So that's the base, right? And I'm going to multiply that by the height. Height is 14.1, right? And I'm going to multiply that by a half because remember, the other formula for area of a triangle is a half base by height. So my base is 2 times the 5.12, right? And I'm multiplying that by the height. The height is 14.1. And then I'm going to multiply that by a half. Guys, do you trust any maths? Let me know, guys. Do we trust any maths?
Yes, sir.
Yeah.
Right. Now, slightly different answers, but they can't give it wrong, right? It's effectively the same thing. I'm not sure why the answer's so different, but Yeah, it's the same thing. It's the same thing. Both methods are 100% correct. Yeah. Right? I wonder if you'll round it off somewhere, boy. Could be. Yeah, but like if you do both methods, both are correct because it's the same concept and they're applying the formulas correctly. They can't take away marks. It's just another way to do the question. Right? So how much of you guys would have done the question like this as opposed to, finding the base and multiplying by the heights? Like, let me know.
But I do it the second way.
Should I find the base and multiply by the heights? What about the rest of you guys? So you know that this is 5.12 and this is 5.12, right? And this is the height. So the base would be 10.24 and the height is 14.1. What would you guys have done? Use the area formula here or use the regular basic one?
I'll use the first one, sir.
Regular basic.
Okay. Right. Let me just check something. Right. Both approaches are correct. So let me just put this over here. Right, so we have the area of the triangle. How am I going to find the area of the semicircle now? I just want somebody to remind me, what is the full area of a circle? What is the formula for the full area of a circle? Area of a circle is? Does anybody remember the formula for a full area of a circle?
Pi r squared, sir.
Right. So what do you think the area of a semicircle will be then?
Pi r squared over 2.
Right, because a semicircle is just half of a?
Half a circle, sir.
Yeah. Okay, guys. So they're telling us to use pi as 22 over 7. So it's going to be 22 over 7, right? Um, my radius. My radius, guys, I'm gonna confuse anybody. If this is the center of the circle, right? Wouldn't the radius just be this length over here? Yes or no?
Yes, sir.
Yes, sir.
Right. And we know the radius is 5.12. We found that previously. So 5.12 squared, right? All over 2. Now, please try to use the exact value, right? So the exact value will be square root of 26.19. So make sure you store that somewhere in your calculator or just recall the previous answer that your calculator would have stored. So if you do the exact thing, let's see what we're going to get. 22 over 7, right? By 5.12 squared all over 2. Let me use the exact value. So that was the square root of 26.19. Are you getting 41.15? But let me know. Let me know what you guys are getting. 41.16. That's what you're supposed to get. Let me know if you guys are getting true. Let's say yes, because I'm going to happening. You good? Yeah, guys, are you getting true?
Yes, sir.
Let's say yes. Let me know if you got true. No, Nicola, I know that. And Darius. Yeah. People that sharp, or I'm not saying sharp. I saw where a Casio. We see that one boy. That was a cube. Do you all know how to plug this expression into a calculator? Like with the fraction on top? Yeah or no?
No, sir.
No? All right. Let me show you what we're going to do, right? So press the fraction button. Press the fraction button. Right? Then press the fraction button again. See that?
Yes, sir.
And you're going to put 22. Press the right arrow, 7 on the bottom. And you're going to open up a bracket. Actually, you don't have to open up a bracket. Actually, you should. So 22 over 7. If you put the brackets, you don't have to put a multiply sign. If you put the multiply sign, you don't have to put brackets. I'm going to put multiply. Multiply by 5.12 squared. Right? Then press the right arrow to go into the denominator, 2. So, first, yes, do that, let me know what you get.
41.19.
Right, so let me see what the answer is using the exact value. If you use the exact value, you will get 41.16. First, yes, what did you get?
41.19.
You see, it's make a good bit of a difference.
So I get the same thing.
You get 41.16.
No, 41.19.
You will use the 5.12.
Yeah.
Try to use the exact value. The exact value, right? The exact value is the square root of 26.19, right? Or you can just store it in your calculator. So if you use the exact value, you're going to get 41.16 as the exact value. Using the exact answer, 41.16. And that will be in meters squared. All right. So guys, we have the area of the triangle and we have the area of the circle. How am I going to find my final answer? Do you have any suggestions? How am I going to find my complete answer?
Add them together.
Yes, because guys, watch. We found this already and we found this already. So we just have to add them. That's all. Just have to add them. So it's going to work out to be. So total area. And what are you guys getting when you add them? So 72.31 plus 41.16. Add that from and let me know what you're getting. Yes, so somebody add that from her. Please, real quiet, boy.
113.47.
113.47. All right, let me just check that with my Casio watch. Give me a second. Yep, I could confirm that is correct. Yeah. Right, the total area is 113.47 meters squared. Right. So guys, is there anybody that's like insanely confused with the calculations that I performed? Or like, nah. Tell me if you understand.
Yeah, understand.
The main thing is you understand the steps. Like the main thing is because like I have like 1 mark for the answer. You need to understand the steps. Like I'm gonna know, guys. Right now, you understand the steps I followed, or like it real confusing here? Tell me.
I understand, so there's just I hope I remember, like, to apply it.
I hope so. That's the thing. Right. So now this paper was very intense, right? So I got better working. So now we want to find the perimeter of the cross section PMQROS. So we want to find the perimeter or the cross section, right? So this perimeter over here. Understand? This entire cross section. This perimeter.
Yes, sir.
Ask that question. Do we know what this and this is?
I believe so.
Yeah, tell me, what are those lengths?
Um,
Feel like you're overthinking it. It's in front of you. Promise. It's right there.
I forget to.
Right? Is 15. Yeah, 15. Right? And this is 15 as well. The only thing we need to figure out is this. We need to figure out that half a circumference. So Janelle, do you remember the formula for circumference of a whole circle?
Pi r squared, sir.
Nah, that's the area. Right? Circumference is actually 2 pi r. So that's the circumference for a whole circle. Wait, and the circumference will be for half a circle.
2 pi r squared over 2.
Exactly. It'll be pi r. And if you're wondering why it's just pi r, the twos would cancel off. Twos would cancel off,
Yes, sir.
right? So the perimeter is just going to be 15. So perimeter is going to be 15 plus 15, right? Plus, we need to figure out the circumference of the semicircle. So tell me now, they told us to use pi as what? What did they tell us to use pi as?
I'm not sure, sir.
Check it out. 22 over 7, right?
Yeah.
Right? And if this is the center of the circle, the radius will be from the center to the circumference. Do we know what that length is? Did we find out anywhere?
14.1, sir.
Nah, that was the 5.12, the OR,
Okay.
right? I feel I could sense the tiredness. Yeah, I could feel the radiating. Right?
Sorry, sir.
That's fine, that's fine. I feel tired too. If I give a little hour break or something, we could come back and like grind till like tonight.
Yeah.
Okay,
I feel like I could, if I get hour break, I could go till 12.
well, would. But like based on how everybody's song is like, wow. Because I feel like if you normally, like, okay, if you see any 15 over here, I feel like you don't know it's 15 normally. But I feel like he was looking at this and he was like, what? Yeah. All right. So if you plug it exactly into the calculator, remember that 5.12 is actually the square root of 26.19. So 22 over 7, right? Multiplied by the square root of 26.19 as the exact value, and you should get 16.08. Let me know if you guys get in 16.08. And that'll be meters. Could anybody else verify that?
Yes, sir. I
Right
can
now,
answer.
the 5.12 is an approximated answer. I'm using the exact value, which is the square root of 26.19. That's the exact value. So I got 16.08.
Yes, I can.
Say no more, say no more.
Yes, sir.
Right? So the perimeter is going to be the 15 plus 15 plus the 16.08. So you're gonna end up with 46.08, I think. Yeah, that should work out 46.08. And that'll be meters, right? Because perimeter is distance around. Right. That was a 9-mark question. Wow. So it's a nine-mark question, right? 9-mark question. All right, let's move on to the parents question, shall we? So who wants to do the parent question with me? Do I have any takers? Adika, you there? This is the last question we're gonna do. Then we'll get like an hour break. And then we're gonna come back. So like, are we enough strong? Everybody's struggling. Darius, you want to do this one first? Darius, you there? Darius, if I can please, boy. No, like it look like it actually stick. Are you hearing what I'm saying? Or like the Wi-Fi bad? Because I see like Darius like freeze.
No, I hear me saying so.
All right, but let me do the question. The game is currently yeah, about
My Wi-Fi is really bad.
Oh, okay. Well, Darius, I see you come back. Any Darius, not pirate, no. Yes, he can.
Yeah,
What?
pirate.
Yeah, boy, what?
Yes, you
Man is the next Jack Sparrow, boy.
see how that port up this what you know one thing.
Yeah. Right.
Wi-Fi connection kind of unstable right now, but
All right, well, Darius, let me see how we can give this a go, right? So, Darius, get this question I read from you. I swear to God, you do this question on me already. We did this already.
yeah, I think so. We do the last one too.
So, get our read from you.
Ship sails from point A to point B, which is 15 kilometers from A on a bearing of 42 degrees.
Hold on. Stop. So, where you seeing the word from by? From where?
A.
From point A. So, where we're going to start off at,
Point A.
right? And you're going to go to where?
Point B.
Right. Now, guys, if the bearing is 42 degrees, do you think this is B or this is B? What do you think is B? 1 or 2?
1.
1. Yeah, guys. What looks like 42 degrees? This or this? 1 or 2? Guys, do you think this looks like 42 degrees?
1.
Now that looks like more than 90, right? This would have to be 42. So this is definitely B. Right? This is definitely B. Right? Darius, and you remember that? And you remember the 10 hours live?
Yes, sir.
I feeling more tired now than I felt during the entire like I don't understand how. I think it's the energy, I think it's the energy. Like I find like people moving dead. So I feel like I'm taking that in, I absorbing that. I feeling the sleep. I need the energy. I feel like my superpower is just to like leech off the energy of others. And it's like if the energy real strong, the vibe real strong, I could go forever. But things something real dead here, boy.
Oh, so no, it's for me, my sinus acting.
Oh, okay. If Ria was here, I'll keep asking me to take off my hat.
Yes, sir. If you know Rihanna, I used to keep the vibe. Since you're not here, I'm feeling like me again. Huh? That was my partner in crime.
Yeah, boy. Yes. Right. So let's interpret the first part. So they're saying from E. So from E, right? You're at E right now. So from E, and you want to go to B. Now they're saying it's 15 kilometers away. And from A, is a bearing of 42. When we do in bearings, it's always from the north line in our direction. What direction?
Clockwise.
Clockwise, right? Clockwise. And this will be the 42 degrees you're talking about. Did that confuse you guys, or like all you understand that so far? And I'm saying that this is 15 kilometers. Let me know that confuse you guys. Okay. I'm not hearing anybody, right? Darius, after it reached point B, what happened next? They're saying the ship then.
The ship then sails to point C, which is 19 kilometers from B on a bearing of 130 degrees.
Oh, all right. So guys, now we are at B, right? And from B, we're gonna go to where? From B, we're going to where?
C.
C, right? Guys, if this is A and this is B, last, we think it's gonna be. We think that's gonna be.
130 degrees.
And I'm gonna be C, right? But I get what you're saying. I get what you're saying. Right? This will be the bearing. This is where the 130 degrees is. So this is 130 degrees here. And how do I know that? I know that because when it reaches B, it sails to point C on a bearing of 130. So to go from B to C, you had to take a bearing of 130 degrees. And that was 19 kilometers. And they wanted us on the diagram to insert the bearings 42 and 130. So we just did that. Right, Darius? I mean, if you understand that.
Yes, sir.
Okay, good. Right, what about the rest of you guys? Did you all understand that, or like it real confusing here? Like real, like come on now.
No, sir.
Understand.
Understand.
All right. And like maybe he was confused, right? And you're gonna put 42 degrees here. Does that make sense? Does this look like 42 degrees? Let's be real. Does that look like 42 degrees? Yes or no?
I don't think so.
Nah, this is actually more than 90, yeah? That's more than 90, for like 91. That can't be 42. That can't be 42, right? So in part two, guys, I already know what it's gonna be, you know. Hear what they saying, calculate the distance. What do you think that's gonna be? Anytime you see the word distance, we have to do.
Cosine.
Exactly, that's gonna be cosine, I bet you. I bet you. Right? Between A and C. Between A and C. Now, there's a little trick with this question, right? You're probably not seeing the included angle. Are you all seeing the included angle?
Yes, it's 90 degrees.
Nah, there's no 90 degrees. I can't assume it's 90 degrees. Let me guess, he was going to say this is 90.
Well, here what? Let me finish off the pass. You see this line right here, sir? Pass it through the B. Like complete it, you know? Like, I don't know if I could write it.
Are you with this?
Like, no, the line here. I'll bring back this line. You see it? I'm gonna take it off.
I see it, I see it. I see what you're talking about. Right?
And then you're gonna take away that from you're taking away 42 degrees from 130.
No, it's correct, eh? Nothing is wrong with that, eh? But here
To
what I say.
find the missing angle C.
Now, we don't want to find for C, eh? In part two, we actually want to calculate the distance between A and C. So we actually want to calculate this distance over here. That's what we want to calculate. Now, anytime you see a distance question, think cosine rule. Think cosine rule. So, let me ask you a question, right? You see that length over here, and you see that length over there. Where do you think the included angle would go? Perhaps it go in the middle, yeah? How many of you understand that?
Yeah.
So we actually need to figure out the angle in the middle. That's what we need to figure out. So guys, remember what I told you? The sum of angles about a line is 180. So guys, if this is 42 degrees, what do you think this is going to be? Is it possible for me to figure that out? Somebody tell me. If this is 42 degrees, how do you think I'm going to figure this out? And you'll see where I'm going with this, right? You'll see. Anybody know? Darius, do you know?
So guess then, right? It involves subtraction.
Yeah, watch. Check it out again, right?
Yeah.
So the sum of angles in a line is 180. 180, right? 180. So if this is 42, how would I figure this out?
Subtracted from 180.
Yeah, subtract it from 180. So that's going to be 180, right? Minus 42. And that is going to give you 138, I believe. Just check that.
Yes, sir.
All right. So guys, my question, all right, is if this is 138 here, right? And this is 130, is it possible for me to find the angle in the middle? Tell me, guys.
Yes, so out of the total and take it away from 360.
Yeah, that's correct. So 360 minus open bracket 138 plus 130. And that's going to be equal to 360. Wait, that will be 38, that'll be 268. So probably 100. No, check that for now. Probably 90 something.
92.
92. Apple Pencil has died. But guys, watch this, right? You're gonna get 92, right? So if that's 92, would it be possible now for me to figure out the distance across the included angle? Yes or no? Tell me, guys. If you know what the included angle is, would it be hard for me to figure out A to C or not? Darius, would it be hard?
No, it wouldn't be hard.
No, sir.
Wouldn't be hard, right?
No.
So like, I can know sometimes people like to figure it out. A map of pencil charges. All right. Should be charged up by now. 9%, sure. So Faith, you there?
Yeah, I'm here.
Yeah, so Faith, are you getting are you getting the 92? I mean, if you're getting that,
Yes.
right? So this is 92 degrees. Question. If this is angle B, what would this line be? This is angle B.
AB.
That be common B.
I mean AC.
You're not wrong, but we're gonna label it common B, right? If this is angle A, what would I call this length?
Common A.
Right, common A, and I'll call the last one common C. So the first thing I'm going to do, I'm going to write down the cosine rule. So the cosine rule for this is going to be B squared, right? And that will be equal to a squared plus c squared, right? Minus 2ac cosine what? What's the included angle? Tell me, guys, what's the included angle?
B.
92 degrees.
Right, the b. So to find for b, it's just going to be the square root of everything there. Right, so let's plug that in quickly and see what we get. So the square root of that's going to be now a is 19, so that's going to be 19 squared, right? C is 15, that's 15 squared, right? Minus 2, open bracket, 19, open bracket, 15, right? Cos 92. So plug that into your calculator and let me know what you're getting.
$24.61.
What about the rest of you guys? Are you all getting 24.61?
Yes, sir.
Yes, sir.
Per se, I say unstoppable with this class you give. You're unstoppable.
No, sir, it's not. I just you have the cosine rule just stick in my brain.
That's good. But the new calculator definitely helping you out. For sure. After today, you should be good with trigonometry.
Yes, I want to try with my sharp calculator.
Don't throw it away. Maybe might need it.
Actually, your mom actually thinks of giving it away.
Yeah, you should give it away to somebody. Actually,
Yeah.
that's like you're giving somebody suffering.
That's true. I think I'm gonna give it another cousin it.
Yeah.
I think my next cousin writing CXC this year, and I tax her.
Where you on it for, boy? Darius, I don't ever yawn. I just like a nocturne. I just like a beast, though. I don't know what's going on. It's crazy. It's a good thing Romano not getting these clips. It's a good thing. It's a good thing. Otherwise, he'll use it against me. But guys, let me understand something, right? This is a 3 mark question. I'm not sure if I remember what I told you about 3 mark questions, right? I told you guys that if you see a 3 mark question, it's probably sine, right? Or cosine rule. Now, guys, in the last question, what we just use? In the last question, what we use?
Cosine rule.
So what do you think we might have to use for this one? To find the
Sine rule.
yeah, we might have to use sine rule. So just keep that in your head, right? Keep that in your head. So determine the bearing of town A from town C. From where? From where? Tell me where. From where? From where?
C.
So I'm going to take my pencil and I'm going to put it by C. So by like right here. And I want to go from C to where? C to where?
A.
A, right? Right. Now to do that, this is my bearing. So this is a line. This is a line connecting C to A, right? That's a line. Now the bearing is going to be that over there. If you are confused by that, tell me. Remember, bearings is always in a clockwise direction from the north line. So we start off from the north line and we going in a clockwise direction until we touch the line connecting A to C. So that over there. Right? Now, guys, check this out, right? If I want to figure out the angle, and it would probably be beneficial if I knew what this was. Yes or no?
Yes, sir.
If I knew what this was, what could I do with that? And 360 degrees. Tell me. if I knew what this was, let me just say that was 91 degrees. How could I figure out the bearing?
Taking it away by 360.
Exactly. So here what we need to do, right? We need to figure out this, and we need to figure out this. This one isn't going to be that hard to figure out. And for serious, remember I told you just now, if you use the cosine rule for the last one, most likely you'll have to use the sine rule here. So it's the same thing as we do in the same procedure. Right? So guys, first things first, let's figure out for this angle, right? That's easy. So remember, I told you guys, sum of angles about a line is 180. So if this is 130 over here, what do you think this is going to be?
50.
Yeah, that's going to be 50, right? Because it had added back to 180. So, okay, part of the puzzle has been completed. Now we need to figure out what this is. So guys, just remind me, what was B? What was the distance between town A and town C? We found it earlier. What is the distance between town A and town C?
24.61.
Right. Guys, do you still have, was that the last calculation you did? Tell me, was that the last calculation you did?
Yes, sir.
Yes, sir.
Well, if it's your last calculation, then you should still have the exact value stored in ANS, ANS. Right? Cool. So let me show you how we're going to figure out this question. Let me show you how. So guys, in this question, we need to figure out an angle, right? An angle. What do we typically use to find an angle? Cosine or sine rule? Remind me, guys, sine or cosine rule? If I want
Sine rule.
Sine rule. So let's write the sine rule for this question. The sine rule is going to be A all over
Sine capital A.
right? A all over sine capital A, and that will be equal to what?
Equal to common B over sine capital B.
Right? And that will be equal to?
C, common C over sine capital C.
Now here this, we need to figure out which two we're going to select. Now, tell me something, right? Tell me something. If I want to find this bearing, we just said that we need to find this big angle over here, right? Now, we already know what this is. That is 50. But we need to figure this out. So what angle we need to find then? That's angle what? Come on, guys. What angle do we need to find for?
For C, so.
Yeah, so we're going to select this one time. We're not going to sit right. We're going to find for that. And do we have a pair of information? Tell me, do we have a pair? So like an angle and a corresponding length.
Yes, sir.
What nice piece of information I have.
That have to say B.
Yeah, guys, what is angle B? Wait, close it off, come on. Again,
92.
92. And guys, what is the length for B?
24.61. Right.
So, tell me, guys, do you think they made us find this for nothing? No. If you didn't realize right, that you had to use it for this question, you would not get the question wrong. So, if you find information, please put it in your diagram. Otherwise, when you see a mark, you might be looking like this. Wait, wait. I'll lose it. Give me a second. You don't want to be looking like this when you see your results, right? So here what I'm saying, guys. As soon as you figure out a piece of information, put it in your diagram. So in the last part, we found that the length of B was 24.61. So I hope you all could see that we have angle B and we have length B. So I'm going to select B. So my formula becomes B over sine B, right, is equal to C over sine C. Now, Perseus, what is B? Come on, Perseus, what is length B?
Is 24.61.
Right? What is sine B? Do we know what angle B is?
Sine 92 degrees.
Right? Do we know what C is?
Yes, sir.
15.
15 over sine capital C.
Right, so guys, we're trying to find the angle here. So you should be expecting, right, sine inverse. Yeah, I have to find sine inverse. So we have two fractions here, so we're going to cross multiply. So Perseus, somehow we're going to end up with a cross multiply.
15 sine
Wait, you're not
92.
wrong. You're not wrong, but I would,
Oh,
I would
so I think I remember my brain going black.
you're not wrong, eh? You're not wrong, you're correct, right? But here what I'm saying, what is the unknown here? What is the unknown?
Unknown as sine C.
So you should probably multiply that out first to be on the left-hand side.
Also 24.61 sine C
Right?
equals 15 sine 92.
Yeah.
I think I get accustomed seeing it on the right hand side now.
It already feels, yeah. That's good. Right. So Perseus, we need to find for sine C first. So how would I find for sine C? By doing what on both sides?
By dividing
Divided by what on both sides?
by 24.61.
Right. Because it would cancel off now. Right? So your final answer would be C is equal to sine inverse of all of that. So if you're confused by that,
No, sir.
is stuff that we have done before. It just looking a little complicated here, but it's things that we have do before. Not that bad. So guys, plenty calculator, let me know what you're getting. So this is the exact value I'm going to use, right? So I'll tell you what I get if I use the exact value. So shift sign,
So I
right?
get 37.51.
Let me tell you what I get if I use the exact value. I use the answer from previous calculation. Again, 37.52. One around it off. What about you guys?
Yes, sir.
Right? So 37.52 degrees. Let me know. You'll understand how I got that? 37.52 degrees?
Yes, sir.
Yes, sir.
A word. So guys, we just now figured it out. We just figured it out, right? So this is 50 degrees here. And this is 37.52. You understand that? So if that is the case, then how am I going to figure out for the red angle? Somebody tell me. Do I have any volunteers?
So by adding up 50 plus 37.52 and taking it away by 360.
Yes, man, that's it. Because this entire thing is a circle, you know. That entire thing is a circle. And if you know what this all of that is, you see that from 360. Yeah, so one time. What are you guys getting when you do this?
Again, 272.48.
272.48.
Yes, sir.
Well, good. That's the answer. Right? I have a question, eh? Can I come on, Sensen? Well, check this, right? If you get an answer that's less than 180, do you think you are correct? Tell me. If you get an answer that's less than 180 for this for this big bearing over here, do you think you're correct or immediately wrong?
Immediately wrong.
Because like watch this, eh? This would be 180, but we clearly going over 180. So I mean, right? Pay attention to that. Right? So that's my answer. I think it should be a formal question. What I noticed was in 2025 May, June, they would have asked a lot and give like not as much marks as it should have been worth, in my opinion.
Yeah, that's unfair. Let's real work for 1 mark.
No, not 1 mark, get 3 marks. But I think it should be worth 4 marks. 1 mark would be ridiculous. I
Like
would
6.
nah, 6 is too much. But yeah, I think they were overdoing it. They really had to think as well. Like real thing. Right? So yeah, that is it for trigonometry. I presume you guys might look back at this video when you have some more stamina, right? Maybe you might look at the parts where you get real tired and try to learn it better. But if you do any questions, any past paper questions, yeah, just let me know. I will correct it. Right? I will correct it.
Okay, sir.
Yes, story. I hear for you. I'll go make it. I'll go make it, man. Yeah, man. I'll how to get out 1 or 2. Or just stop.
Says only on this topic where it don't matter.
Say that again.
Only on this topic where it don't matter.
It don't matter. If I do a question, I will check it. Right? Like I say, if I put any work, I'll be there. You gotta help yourself to be helped. That's what they say in the school. So yeah, you guys understand trigonometry at least like a little better. Like a little better.
Yeah, a whole lot better.
That's really good. So just to summarize, like in 2 minutes, tell me what I'm gonna do if I have right angle triangles. Right angle triangles. What theorems I can use? What things I can use?
Pythagoras theorem and trigonometry.
Right? If I have triangles that are not 90 degrees,
Sine
Sine and cosine.
when would I use cosine?
When it says they have
included
included angle.
Right, right. And I will use sine rule in every other situation, right? So you would typically see them asking you, if they're asking for a length or a distance, think cosine. If they ask you for an angle, think sine, right? Yeah. And parents, we put on the note line whenever you see the word what?
From
Right, from, right? And you're always going on one direction, clockwise or anti-clockwise.
clockwise.
Right. And the sum of angles in a straight line is?
180.
And for a circle?
360.
Great. Great, guys. Nice. So like, let me show how much marks I like you get, right? So like, this is 3, 3, 4, 5, 5, 6. So that, okay, that 15 marks. For your trigonometry, like for all your trigonometry questions, cut it out 3 papers, 15 marks. Yeah. All right. So here what? We can start back in the night, right? I want to do algebra. Prepare yourself for level vibes. So like make sure you eat food and sing, boy. Make sure you eat food. Right? Stock up.
So I'll go till 12 o'clock.
All right. Well, go for as long as you could. Right? We're gonna algebra, right? And relations and functions and graphs. All right, so let me just see how this thing going.
So if we have time, we could go through some coordinate geometry.
Sure. Sure. Coordinate geometry and whatnot, like you're talking about lines and stuff, like y is equal to mx plus c and what have you. Um, that would fall under this. Yeah. So section 6 and section 7 is like some heavy hitters, right? So we finish this. Yay! Finish it. Let's take a little while. I want to look at these two next, right? We could definitely finish these two like in one day, like easily, right? So this more than likely we're gonna take tonight and tomorrow, finish this completely, right? Leave no stone on like leave no stone unturned, right? Then, and this is the second day, right? So second, right? Yeah, man, we will figure it out. We'll figure it out. And don't worry, if the 4 days is not enough, right? Because I'm not gonna rush anything if I rush the material, or you're not gonna learn anything. Don't make sense. So if 4 days is not enough, don't worry. I crazy. I would go till we finish. Right?
I don't mind because I mean CXC is right 26, but we still have time, I believe.
Yes, man. But we're going to take we time and do not rushing anything. We're going to take we time, understand everything, cover everything, right? And I'll see you later tonight. Let me just decide on that time. What do you think? An hour or 1.5? What do you think? Hour or 1.5?
Hour and a half.
Hour and a half, so
All right, so we will meet back at 5, 6, 7 p.m., right? And we go into whatever. Hey, that'll be like live 7 to 10 p.m. or really 7 to 1 a.m.
Of course.
Right. I enjoy a night owl, you know. I don't like this dating.
Same. All my studying, I was doing night. I was full all nighters.
Same boy. I just pull all weeks.
I think I so bad yet that.
Like when I knew, yeah, I just wake a whole week and just keep grinding. Yeah, boy. Ridiculous. But yeah, guys, I will see you at 7 o'clock. It was a good session, man. I'm gonna send these notes one time as well. Later. See you at 7.
so,
Alright, that's
so, I so I just asking you know anything about CSEC using having exams on laptops, it being online?
I hear that pretty soon the exam's gonna be a hybrid, but in my personal opinion, I doubt it will ever fully be online, right?
No, so
So they
because
send
January.
yeah,
emails, they say.
in
Yeah.
my email they said the maths exam was gonna be online and they would have
Yeah, in
computers for
January.
everybody to do it.
Send me an email, send me an email, send me real source.
Actually started it in 2023.
But like, how are gonna work? They need to see the working.
So they say how the paper two gonna be like on a screen and you had to write down your working
I
down
got
there.
cause real rocket for that because I went June and that was very chaotic when we had the paper one, especially the people and them was not prepared properly and it was very disorganized. And that cut back into the time and they did not give us any more time.
I don't understand why they can't just print the damn paper, boy. Sorry for my language.
Exactly.
Just
Also,
boy.
for like the geometry questions, I just trace over the triangles and stuff, and that means I
Same,
can't do it.
same.
No, like I
It
fully
was,
understand because like how I doing these questions on the screen is like it would make a lot more sense. Like a lot of these questions make sense if they be on paper. Like no, I don't know what they're doing. Yes, I don't know what they're doing.
I'm trying to frustrate me. I, my
I
brain
don't
and hurt and
understand.
everything.
I don't understand why when you're signing up and registering for the exam, they would ask us if we want to do it online, and we choose no, and now all of a sudden we get an email saying it's going to be online.
Exactly,
That
exactly.
is ridiculous. Some more means. Some more.
Okay.
I will talk to some people. I'll see what we're talk to some peers. Talk to some other teachers that more experience than me, like in the game longer. Like no more people. Well, that's ridiculous. But yeah, I will see you at 7 o'clock. Level vibes tonight. Yeah? Algebra, relations, and functions. That's like a 20 marks in the exam, right? Yeah, guys. Later.
Bye.
Bye bye.
Later.
Later, sir.
Later.